Welcome back, everyone. In this video, we are going to start typing out our Redux-Saga. Now, typing sagas is going to allow us to start really understanding the nuances of why typing them is so challenging. There are ways to make it easier, and it starts with including a new library as well as a new plugin. So in order for us to include the new library, what we'll say is yarn add typed Redux-Saga. So type Redux-Saga is a library that extends upon it this extension of typing out generators. And typing out generators is typically very challenging. Other than the type Redux-Saga, we also need to include a macro for Babel. Now, I mentioned before that we will talk about Babel at the very end, but for now, all we need to really do is just include this additional dev dependency. So yarn add -dev babel -plugin -macros. Now that we have everything installed, going back into our code base, what we want to do is we want to start migrating over our sagas. So to begin, I'm going to switch this category saga over to a .ts file. The reason why we have typed Redux-Saga is that we no longer need to use Redux-Saga effects. Essentially, typed Redux-Saga allows us to leverage a typed version of each of these effect creators. The way to use them, though, is that instead of calling yield, we will now be calling yield star. So the difference between yield and yield star is that yield typically yields the generator, and you're still inside of JavaScript generator land that handles the actual execution of those generator functions. Yield star is similar, but it essentially hands it off to the Redux-Saga library. So Redux-Saga is going to behave the same way, except because it's Redux-Saga, Redux-Saga can coordinate and identify what these effects are, what their return values are going to be. Because if you remember with a saga can have multiple yield steps. Typically with a generator, it's very difficult to determine what the output of these generators are because each yield is an output of the next call in the generator. If you remember from our generator video. If you're unfamiliar, go back, rewatch that generator video because a lot of the difference between sagas and generators is extremely minimal. The main thing is just that you can see sagas as generators that have Redux bindings within them. But the other thing is that Redux-Saga, the library, becomes the thing that actually drives and calls the generator in order to move it forward. But along the way, what it does is it's able to now determine the types of the values that come back. And by doing it like this, now we can see that we are getting the appropriate type errors. Now here, when we look at this type error, what is it that we see that's wrong? We notice that this is a very extensive mention inside of the overload matches, all of that stuff. Right now, that's not as important. The key thing that we see is that up here it says type saga generator is not an array type or a string type. The compiler needs to use this option down level iteration to allow the iterating of iterators. So what we need to do is, in order for us to properly parse this file, we need to go into our tsconfig.json and inside of our compiler options. Now what we want to add is down level iteration, except we want to set it to true. On save here though, this may not work the way that we expect it to. If we go back to our category saga, sometimes if you hover over, you'll notice that the type errors have not gone away and you'll still see it. In our case, it did end up working for me, but if it does not for you, all you need to do is go into your VS Code and just close it. Make sure you close all of your VS Code, restart it, and what happens is that the VS Code compiler will rerun and hopefully pick up the correct changes from your tsconfig.json. It really happens when your computer is a little older and a little slower. Sometimes VS Code takes a lot of resources, so as a result, the Typescript compiler and the linting might be a little bit behind. But now we see that everything is working here. Right away, we actually see that we have this error. Now, this error is due to the fact that this function does not receive any actual properties, but here I'm clearly passing it categories. So this is actually a mistake on my part. In JavaScript, it wouldn't throw an error because if you pass a parameter to the function still gets invoked, all of our code still works. But in my particular case, I'm passing a property in TypeScript that does not actually expect in this function. This function takes no properties. So that's actually one great thing that we can quickly fix to make our code less confusing. The next error, and this is again that catch error I was mentioning. In this catch can catch any type of error. So for us, it does not know what this is. It's always going to throw unknown, even though we're expecting a parameter of error. So here we might as well just cast this to error because we know that if this fails, we will be getting an error. And that's really all we needed to do in order for our sagas to be typed now. So if you look at the saga now, you'll look inside of this generator definition. You'll see that what it does is it makes a call effect as the categories array. So each of these different values in the first part of the generator tells you what the yield values will be. One is going to be a call effect that returns back the category array. Now the category array is the return of this get categories and documents call. So yield, as you can clearly tell, of that one will give you a call effect, which I mentioned is an effect generated by Redux-Saga, and that returns you back the category array. The next is the yield of the put effect. It does fetch categories success. Finally, we have also a put effect of fetch categories failed. These are the three different possible yields that can come out of fetch categories async. So that is essentially what the first parameter of the generator represents. The next one is the return value. So this is if inside of our generator function, we return something as a final value, which we rarely ever do inside of our generators. So for us, that's going to be void. And then the third argument of the generator are any values that we pass into the next call in order for them to get passed into the subsequent yield calls. So for us, we generally also don't really handle those. So most of the time, we're really just focused on this initial typing right here for the generator. But as we notice with the yield star call inside of typed Redux-Saga, what will happen is that this inference gets deferred to the actual Redux-Saga library. And typed Redux-Saga is smart enough to actually go through it and infer all the required types for any sagas and generators that get called in order to build out this actual type structure. So we really don't have to do it ourselves. So now that we've typed category saga, we have to type user sagas. And user sagas are going to be more complicated because there's a lot more saga code in there, and there's actually a couple adjustments we need to make in order to make it fit inside of Typescript. So join me in the next video. Let's start typing out user sagas. Welcome back, everyone. In this video, we are going to migrate user sagas over to Typescript. So first, let's modify this to a .ts file, and you will see that this file is going to explode in TypeScript errors. A lot of typing that we need to do because, of course, this is way more verbose. So to begin with, let's start from the top. First, we want to migrate from Redux-Saga effects over to typed Redux-Saga. And now, earlier, we had just used typed Redux-Saga, but we can actually also use /macro. /macro will allow us to essentially leverage that Babel macro plugin. What is the Babel macro plugin? So generally speaking, when it comes to using third-party libraries or builders of third-party libraries, what they have to do in order for them to add additional steps during the code transformation or the compilation step is they have to create something like a Babel plugin that you need to install. This plugin is going to be unique to their library in order for the code to compile the way that they want it to interact with the Babel step. However, Babel has defined a very clear step on how to actually create this type of tool inside of Babel. So it's kind of like you can see it as a standard interface for libraries to use. That's what we installed, the Babel plugin macros. It's not actually made by Babel. It's made by a great developer by the name of Kent C. Dodds, but it's very popular because by installing just this plugin, if a third-party library uses that interface that is created by this Babel macro plugin, it doesn't actually require you to install any more additional Babel plugins. So Type Redux-Saga has actually also integrated with this Babel plugin macro in order to create this additional macro plugin. And what it mainly does versus using Type Redux-Saga is it just simplifies the final output of the actual actions that get created by the effects. We won't really see those effects, but generally speaking, it's really helpful for us later on, and we'll talk about that later. For now, what we want to use is this Type Redux-Saga macro. So similarly, we're also going to update the other Saga code we had so that we're also using the macro. So now that we have switched over, let's talk about this function star force you get snapshot from user auth. So first, we notice that we have to type, of course, both of these parameters that we're passing inside. So the first thing we need to do is we need to import user from Firebase auth, which is the type, because that's what our user auth is going to be. And we can just cast this over onto the user auth. As for additional details, this comes from our Firebase utils. So here, down here, we can just add in additional information, which is our type. Moving on, we know we need to switch this yield over to a yield star. And looking inside here, what we notice is that ID and data, these are properties that may not exist because the query document snapshot, at this point, we don't know if there is a guarantee that we will get this snapshot. Because create user document from auth, if you remember, we could get null, which means that we'll return back void, because then the function exits. Or if it's not null and we do indeed get a proper user auth object, then we will return a snapshot for that object. So as a result, what we need to do is we need to make sure that if this exists in the first place. So we can say if user snapshot, then we will actually try and yield out this value. And there you see that this value is now clear. But this value now throws an error because it says that we do not have an ID on the type of user data. So sign-in success is expecting a user data object right here. But the problem is that inside, when we actually append it, again, we do append the ID from somewhere else. So what we can do here is we can actually extend this type to have the ID of string. Because if you remember inside of our Saga, what we were doing is that we were getting the ID from user snapshot ID. It doesn't actually belong on user snapshot.data, which is what we have in Firebase. We discussed this earlier when we first created this method. We had to get the ID from the snapshot. So now we have to, of course, extend what the actual action creator is expecting because the ID is not coming from the snapshot data. It's coming from the snapshot object itself. So that's all we needed to do. Next, of course, as with the error, we need to make sure to set this as an error explicitly because our sign and fail is expecting an error type. And we know that when this throws an error, it's going to be an error type anyways. And now moving on here, again, the easiest way to convert all of these yields for them to work is just to switch all of them over to yield star. So let's first just do that. Now, moving back to our type error. Here we see that we actually have an issue. We're missing a property. The property that we're missing is actually the additional details being passed here as the second argument inside of get snapshot from user auth, but the third argument of call. The reason for this is because we did not make this optional. So in order for us to fix this, we just have to define this as an optional parameter. And now the call will fix. As again, with this error, we just need to set this as error. And now moving onwards, we can look at sign in with email. Here what we have is that we know that sign in with email is getting called with a specific action. The place where we call it is that whenever we take latest, user action types.email sign in start. Take latest will pass the action that matches into our actual Saga. So that means that this is actually a action that we are destructuring. The specific action that we are destructuring here is in fact email sign in start. So we just need to import that from our types. This, I believe, is inside of our user action folder. There it is. So we can just copy this and we can just say that this is what we are trying to destructure all of our values off of. And you'll notice we'll get email and password as strings because those are the parameters on our payload. Similarly, inside of this sign in call here, we again are getting back a snapshot from sign in with auth user and email and password. As we can see, we get back a promise of the user credential. We might also get back undefined. The reason we get back undefined is because we might return early. So this is why we might get undefined. So what we need to do is we need to do a similar check as to what we had above here. So what we'll say is that instead, we're not getting back a user snapshot from here. We're actually getting back a user credential. But this credential, of course, might be undefined. So we'll first do a check. Is there a user credential? If there is, then we will destructure off the user from this user credential, upon which we will yield out a call in order to get the snapshot from user auth, passing it onwards to our next saga. As well, we need to make sure that we are casting this error. But there we go. This is it. We have now typed out roughly the basis for the majority of these sagas. So what I want you to do is take some of these lessons that you've learned throughout this video and try and type the rest. I'll continue and we'll do it together in the next video, but I want you to practice. So try it out and I'll see you in the next video. Welcome back, everyone. Let's continue finishing typing out these different user sagas. So here for is authenticated, it's just an error casting as we have to do. Here inside of signup, where do we actually call our signup saga? So if we scroll down, we notice that we call our signup saga on signup start. So this happens when we get that action, signup start. So here, let's scroll up and let's bring in the corresponding action type. So this one, as I mentioned, is going to be our sign up start, which we will bring in and set as the action that we receive for this parameter. Similarly here, we are also calling our create auth user with email and password, which is very similar to our sign in auth user with email and password. At the very least, what we know is that we are getting back a user credential. So we are going to replicate the code we have above, where we get some user credential, upon which we perform a check first to see, is it not undefined? Then we will destructure off the user from the user credential, upon which we finally actually yield out the next subsequent call. Now, signup success gives us an error call here. So here we see that user is authenticated by this credential, but user is not assignable to the parameter type of user data. Now, the reason we're throwing this error is because our signup success has defined user to be user data. So this most likely means that we actually mistyped our signup success definition. Here, we are defining user as user data, but this is most likely incorrect. We're actually expecting this to be of the type user that we get from a user credential. So the reason why is because when you sign up, you are authenticating. When you authenticate, it does not mean that you have an instance of the user inside of our Firestore. User data is the data that comes from the user snapshot, which is an instance inside of Firestore data. The user that comes from a user credential is just that auth information. Again, I know it's very confusing because of Firebase and its naming conventions, but here we know that what we need to bring this from is Firebase/auth. So with the user now, what we can do is properly fix our typing issue. So inside of signup success, we need to update it here. And we also need to update the action itself because the action definition most likely has it as also user data. So let's fix that. Let's save this, go back to our Saga, and now we see that everything is fixed. We know that this is correct because we followed the string of our logic, but also because our Sagas were working, which means that the Saga code is correct. It's just that our typing was off. So moving on, we now need to also type this sign up failed. We'll say this as error. Similarly, we also need to type our sign out failed as error, and then our sign in after sign up. This Saga gets called specifically after sign up success. So we need to get the action for sign up success. So let's import that in. Here we were missing a comma, and let's bring in sign up success. And now we'll just scroll back down to our sign in after sign up and cast the appropriate action, which should also fix our type error. So that's it. We've finished typing out our user Saga. So again, this is probably the most complicated portion of our code, but with just a little bit of thinking about everything that we've already learned as far as typing goes, we were very easily able to type everything now and make it TypeScript compliant. So now that we've finished typing our user Saga, what we want to do next is we also want to make sure to type our root Saga. So our root Saga here, we also want to convert this to a .ts file. And of course, instead of Redux-Saga effects, we will bring in our typed Redux-Saga /macro. And we need to switch this yield to a yield star. Save this. And there we go. We have now also typed out root Saga. So now that we have all of our Sagas typed, we can now begin actually typing out the remainder of our code. So one quick thing, before you start typing out these components, there's a couple things we're going to have to adjust as we go. But first, let's just do a quick check and make sure that we have no type errors. We see that our code is still working. We see that our add to cart is working. So all of our Sagas are properly typed. All of our code is valid. So now that that's done, let's move on to typing our rather complex React components that we've made inside of our Crwn-Clothing application. I'll see you in the next video. Welcome back, everyone. In this upcoming video section, we are going to type the remainder of the components inside of our Crwn-Clothing project. To begin with, we need to include the types for some of our libraries, the most important one being style components. So just like we did with Redux Logger, we are going to yarn add at types/styled-components. So as this is installing, we're going to come over and we're going to first start styling out our button component. So to begin with, I want you to convert both the component.jsx and the styles.jsx over to the TSX versions. What you'll notice inside of our styles component is that most of these components that get generated from style components actually already are typed for us. So here you'll notice that this base button is of a style component type button, and then there are some subsequent parameters on the style component. For us, we can just trust the inference. It's rare that we need to modify these. So what we can do is just trust that the styling that has been done on these components is correct. When we come to our button component.tsx, we need to think about the logic around how we've created our code. So first off, these button classes are no longer going to be a const because as we saw, we want these to be constant values that move around. So we're going to convert this to an enum as we did with our action types. And we're going to similarly switch these colons over to equals. And then if we save this, we also need to now check why there are, oh no, that was just the compiler being a little slow. So again, as I mentioned, depending on the speed of your computer, the compiler on VS Code might lag a little bit behind. So if you ever see something where it doesn't look accurate, just wait a little bit or restart VS Code. Unfortunately, TypeScript compiler is pretty intense on the system. It's just one of those things that lags behind. Now here inside, get button. Let's think about what this does. This will definitely return us back one of these 3 style component buttons. So what we can say is that this function gives back type of base button, because base button is a component. Now, type of gives us the actual type on the base button. So it will give us this style component button type, which all 3 of these buttons are. They are all variations of style component button because they're all based off of the base button. The additional parameter that we need to also do is that we need to think about how this button component is actually going to render. So as you can tell, we need to define button props. Now, if you want to define props inside of our component, as we've done before, one main way that we did inside of our Monsters-Rolodex was that we defined the type of the props like so. And inside, we would add any additional props that were not typical to our component. However, we know that we have children inside of these props, and we don't actually want to define the children ourselves. This is something that React is already attached. So chances are when you look at something, and this is not your own implementation, but something that the underlying library or third-party library does for you, chances are there's something in the types that does this for you. So for us, we are using functional components. We can import in the FC type, which stands for functional component, from React. This FC type is going to be what this button is. So we can actually say FC, and then we can pass it the button props as the generic. What this will do is it's equivalent to actually passing the button props onto this section as we were used to doing before. So you could essentially do button props like this, or if you use the FC type, it will actually infer the children, which is really handy for us. So as you can see now, this children is valid because React knows that it's a React node because this button is of the functional component type, which extends children as part of its props definition. What we do need to add is button type is loading, but also the fact that all of the other props that we might spread through onto custom button here, this is going to be part of just a button. Remember, we are extending on the base type of style component.button, which is just a React button. So we want all of those button props as part of the signature that we accept as props on this component. So we'll first define the props that we have unique to our button, which is really just this button type that derives which of these button styles you want, and then is loading, which determines to show the spinner or the children. So first off, we'll say that button type, which is an optional parameter because by default, the button type fallback is base button, as we can see here. So we can say that button type is one of these button type classes inside of the enum. Next, what we need is loading. Is loading is also optional. And here we can say that this is a Boolean value. From here now, we need to extend the other props that exist on a button. In order for us to get those, we actually need to import in button HTML attributes because React has specific attribute bindings for their button component. And this is called button HTML attributes. And then what we can do is use an intersection type right here, and we'll say button HTML attributes for the HTML button element. And now our button is able to accept all of those other parameters that we are familiar with, such as the actual type, because we have button type, but remember there is a type attribute that you can use if you want to say that it's a submit button, or if it's just a regular button, or if it's another type of button. These are the ways that you can get all of those typical button attributes. So now we have typed out this button, and we can save this, and we can now move on to the remainder of our components. Now, typing buttons and typing inputs typically are the most challenging because these custom components do extend upon the existing components that are present inside of the React ecosystem. Really, our buttons just add on to some existing component. For us, this is the button component. We're just customizing it, adding some additional functionality. So you need to figure out which attribute you need from those original ones in order to extend upon them. We saw this inside of our Monsters-Rolodex when we did with the form input. So this is an important thing to remember. If you are writing a component that extends upon an existing React component in HTML, there is most likely a corresponding component HTML attributes type that you want to pass a similar HTML element for. And from there, you can now extend all of those existing bindings that exist of those attributes. Now, speaking of form input, that's the next component that we're going to type out. So join me in the next video where we'll type it together. I'll see you there. Welcome back, everyone. Let's start typing out our form input component. To begin, we want to convert this over from JSX to TSX, both the form input component as well as the styles. And first, you'll notice immediately that our form input label has a type error. The reason is that shrink is a any call. And the reason for this is because the form input component for form input label is a component and we have not defined any props on it. So we're trying to use props on this component despite the fact that the props are not defined. So here, defining props for these style components is the exact same as defining props for any component because these are really just components. So here we'll say type form input label props is going to be equal to us receiving some shrink value, which is optional. And this is a Boolean. And what we'll say is that form input label props needs to be passed to this component as the props. So the great thing about style components is that you can just pass it as a generic to the style.label because by default, that's the definition. They take some generic value and then add it as the actual props that it expects to receive. And now you'll see that shrink is indeed a Boolean value. So now we can save this and then go back to our form input component and start typing this out. So as you can tell, as I mentioned before, we are really just leveraging the underlying input component in order for us to extend all of these additional features onto it. But the input component, just like the button component, has corresponding HTML attributes that we want from React. So we're going to import in input HTML attributes. And we're also going to implement FC because we need this to be a functional component. What we're going to do now is we're going to type out these form input props. So this is going to be first the label value, which is our unique value, which we expect to be a string. And then from here, we are going to create an intersection with input HTML attributes. So we want all of the input HTML attributes of a HTML input element. And now we are going to say that form input is of type functional component with the form input props. So now we've solved our props issue for the type. However, the problem here is that if you look at this, there's a chance that the other props object is undefined, assuming that no props are passed. So here what we can say is that first, if this is the case, what we want to do is we want to ensure that this shrink always receives a Boolean because shrink is receiving essentially a Boolean value. So what we can do is we can say Boolean on this value like so. And the first thing we'll check is there other props. So is other props.value, is this exist? If it does, then can we render other props.value? Well, now we'll notice that length might not exist because on this particular case, we don't know what we could get back. Length might not exist on the value coming back as a number because inputs can receive both strings and numbers. So if that's the case, then we need to do another check to ensure, is this going to be a string? So here we'll say is type of other props.value equal to a string. If it's equal to a string as well, then finally, I want you to check if there's a length. And now we are now correctly passing and properly typing through our form input. Now that we've done our form input, let's think about where they might get used. The places where we insert inputs is in both the sign-in form and the sign-up form. So let's type out these forms. So again, we are going to convert this over to a TSX file. Now, first off, to begin, we can check in our sign-in-form.styles, and we see that none of our style components receive props. So we don't need to type any of these. We can focus exclusively on our sign-in-form.component. So here, we also notice that our sign-in-form doesn't receive props, but our handle submit and our handle change do receive props. Now we need to type these. We've already typed handle change before, which essentially is what we pass the on change of an input. So we can expect similarly then that handle submit is going to follow a similar pattern where we receive some kind of event from React. What kind of event is it? We can just convert this over to a function signature, and we can just put E, hover over it. We see that it is of type form event. So we need to import in form event in order for us to actually type these two fields. So first we're going to come up here and we're going to say, give me the form event, and also for the change handler, give me the change event. Using these two now, we can say that the event that we receive from handle submit will be of type form event. And we're going to pass it, as always, HTML form element most likely. And that's exactly what we see. Similarly, for our handle change, we are going to pass in change event with HTML input element being the type of change event that we're registering. Now, if we save this, we see we have no more type errors for our sign-in form. So we can move on to our sign-up form. So let's first convert these files over to TSX files. We notice there, inside of our styles, there are no props, so we don't need to worry about typing this one. We can now just do our sign-up form component. With our sign-up form component, we notice that we actually have some leftovers that we aren't using from our inputs. We can just get rid of that. And now again, we see that there are two different type errors. We'll have the two different events for submit and for handle change. And we also see we get an error code. Now, the first one I want to tackle is just the event. So as always, just like we did with React, we are going to bring in two events. One is the form event for the submit. One is the change event for the input. So I'm going to say that this handle event is a form event of the HTML form element. And then for our handle change, this is going to be a change event for HTML input element. Now, what about this error code? So here you might be thinking, what is this error? Well, we're actually catching this error inside of our auth start, which is what signup start gives us back if we catch. So this is where we may not actually get the error that we expect. What we need to do is we need to get the auth error. So this is where inside we can say, okay, if we get some kind of authentication error, we need to import in most likely some kind of error from Firebase. And the chances are it's actually something that exists. So inside of Firebase /auth, there are two types. One is the auth error type. And here we see there's even auth error codes. So what's great about this is that we can take this auth error and we can actually directly modify the code here so that we're not even hard coding these values. We actually get these directly from Firebase. So the first thing we need to do is say that this error code is a specific type of error. So error as auth error, because we know this is an error from Firebase auth. .code must exist on the auth error because that's where we're reading it from. And now instead of matching this string ourselves, we can say auth error codes dot, and then now we can just find the one that we had before, which is email exists. As you can see when hovering over this, this was the same string that we had earlier, auth email already in use. So amazing. We don't even have to now reference our own dependency of figuring out what that string was. We can save this now, and now we have our forms also fully typed. So that is really great. We've typed our forms, we've typed our inputs, we've also typed out our buttons. So now that we've typed this, let's start typing something else that might be a little challenging, which is our SVG icons. So let's tackle that in the next video. Welcome back, everyone. In this video, we're going to type out our cart icon. So to begin, let's switch these over to TSX files. And as you can notice, cart icon taking no props, no problem. But when we look inside of our cart icon component, what do we notice? We notice that here, Typescript cannot find this module for SVGs. The reason for this actually has to do with our tsconfig. We need to tell Typescript to include checking for alternative file types and then typing them inside of a React world. Now, this is where we need to actually declare a global type, just like we did before when we added something to the window. If you remember, we were working with Redux DevTools. So inside of our component, first what we need to do is we need to create a global file that we can add some additional typing to. I'm going to call it custom.d.ts. Now, the .d.ts is some special file that Typescript is looking for. So let's add it inside the source. We're going to make a new file called custom.d.ts. Inside of our custom.d.ts, we are going to declare a module where we register any path where we go star.svg. So we're recognizing any pathways. Again, remember, we're importing. So Typescript needs to be able to import the appropriate modules because that's really what we're importing. All of these are considered modules. We're importing any module that ends in a .svg file according to the following rules. Now, first, we want to just register the fact there's something in here that we want to export. We're going to say const source is equal to a string because essentially that's what's going to come out of it. And then we're going to export by default source. So that's how we're going to get the files. It's just going to be some value that gets initialized and then it's going to export it out by default in order for us to declare these as registerable TypeScript modules, importable and exportable. So by default, we need to append this type of export so that TypeScript knows, hey, you're exporting something from this. It's going to be a string because all files actually get converted to strings. And then once you import that in, React knows what to do with it. It'll parse it appropriately. React is already doing all that under the hood. It's really TypeScript that needs to register that. So let's save that and let's include this new custom.d.ts file inside of our tsconfig. For us to do this, we can include it inside of our include, and we can just say include source / and then custom.d.ts. And now that we've included this inside of our config, so that we know that, hey, inside of here, I want you to register these as specific files as part of your configuration. If we go back to cart icon, we'll notice that we're no longer getting that module error. We can successfully see that this is, hey, a module where we can bring in the SVG. But now we're seeing, oh, this is no longer an exportable member. What you're exporting is a string. You're not actually exporting a React component. Now, this is where, in order for us to turn this into a component, because remember, React under the hood is already doing all this. We just need TypeScript to register that this is happening. We got to extend upon this module. So first, what we're going to do is we're going to import in React, and we need to require this from React. What we're going to do with this React library is we're going to export const a React component. So we're going to say React component, which is the name of what we're importing. Remember, right here, you want to think about these imports and exports. First, we're exporting by default the source. But we can also export a member, which is what happens here when you do a named import. Remember, with these squiggly braces, you need some const to be exported. That's the only way that we can make sure that we can import it inside of these squiggly braces. This means that we're importing something, React component. That's why when you don't need the as shopping cart, this needs to be something that is actually exportable as a value from this file. Us saying as shopping icon is just us renaming the variable. But React component needs to live as a valid variable inside of this shoppingbag.svg that TypeScript can register is actually valid. Again, this is what we're saying here. We're saying, hey, there is some constant that is going to be exported called React component. And this is going to be of the type react.fc. It's a functional component. And what it is a SVG props. So again, this is a functional component. We have SVG props being passed in, and the props is going to be an SVGE element. So these are just settings that need to be set. If this seems confusing, again, once you go through enough of these TypeScript patterns and documentation, you're going to essentially figure out what are these components mainly. This is a lot of configuration with TypeScript that we just need to do. I'm not actually typing anything through some deeper knowledge of all of this stuff. It's really just the fact that I've read through a lot of the documentation, so I understand what's needed in order for these components to actually render and their types. But that's what we need to bring in now. And inside, we now notice that this is working because essentially we've defined what this React component is. If you hover over it, right there, you see we have a React FC with SVG as the props, where the prop types are based off of an SVG element. Now, because we did it for this one, it will work for all the others. If I remember correctly, our navigation routes component also has similarly an import where we're bringing in some React component like so. So here we can, in fact, convert this one as well. So first, I'm going to convert the styles to a TSX file, and I'm going to convert the component also to TSX. And now looking inside, looking at this component, if you hover over React component, you notice it is a valid prop. Looking through this file, there are no type concerns because, again, this is a very straightforward component. We're using all these hooks that are already typed for us, so there's nothing additional that we need to type. We started with Redux. All of our Redux portions are all properly typed. So there we go. We now learned how to type SVGs inside of React. Chances are, whenever you need to do anything with SVGs inside of React using this very common pattern, you just need to also declare this additional module and then include it inside of your tsconfig. Now that we know this, let's continue typing the rest of our components. Welcome back, everyone. In this video, we are going to talk about useParams. So useParams comes from React Router v6. When we type this, you'll notice something interesting happens. First, we're going to convert category component as well as the category styles. And looking inside of styles, of course, we see no props, so we don't need to worry about that. But when you come in here, what do you notice? You notice here that category might be string or undefined. The reason for this is because useParams gives you back from an object of potential parameters inside of the URL any matches that exist from the object. The problem here is that we know inside of our code, this category can only be rendered if the route matches that URL parameter. Think about it. This category, it lives inside of the shop component. We know that the only way that this component will ever render is if this path matches with the category value already in the URL parameter. For us, it's an absolute known that this component will never render unless this parameter is present. But React Router and TypeScript do not know that. TypeScript only knows that useParameter can return you back these params, and this params could be empty. If that's the case, then what we have to do is we have to tell TypeScript that we are expecting there to definitely be a value. So what we can say is that we want some kind of type, actually not even exportable, let's just say a type of category route params. And this is going to have category as a string. Now, what we want to do with these parameters is we want to tell TypeScript, just assume that these are always going to be present. useParams actually can take a value. If you hover over it, you'll notice that it can take a string value. And what is this string value going to be? Well, here we're going to pass it not just category route parameters, but we're going to say, hey, these are only keys of category route parameters. The reason we do it like this is because if there are additional parameters, we want to be able to have them accessible. So saying, hey, this is a key of category route parameters means that you're either going to get a category or you're going to get any other additional values that are potentially parameters that are viable. But beyond that, we need to enforce that there are definitely going to be these parameters. So here we're going to say as category route parameters, meaning that you can assume that this is non-optional. This must be a string value. So here now, these category is no longer going to be undefined. It's definitely going to be a string. So now we can now properly identify that these categories are always going to be present. So this is one of those things about useParam. You need to be able to enforce that, hey, I know logically that because this is in a route, this must only render if that category is actually inside of the URL. So in order to do that, you're going to have to use this pattern. Now, the last component that is going to be a little bit interesting to type is going to be our payment form component. Now, payment form, the reason why it's interesting is because we are interfacing with a third-party library, which is Stripe. And typing around a third-party library is always going to require us to have a bit of finesse in understanding how it works. So to begin with, we check again. Our styles does not have any props in the components. No problem. We don't need to worry about it. What about the payment form component? Well, first off, we see that our payment handler component has a problem because, again, we need to type this according to the form, the fact that this is indeed a form type. So we already know that we need to bring in some of those React elements that we've already done in order to type out a form event. So let's bring that in. And now let's type this out as an HTML form element, like so. But inside, you'll notice that here we see that card must receive a valid Stripe card element. We cannot pass in null. Null is not assignable to the card for this payment method. So this means that elements.getElementCardElement might potentially return us back null. If this is the case, we need to perform a typeguard check. So we've done this before, but we need to probably get a little bit more considerate about how we're going to do this. So first, I'm actually going to cast this as a variable. So I'm going to say const card details is equal to elements.getElement of card element. If this card details right here is not present, we can say if bang card details, or even more explicitly, if card details is equal to null, then just exit. Now, what you'll notice is that when we switch this out over to card details, that now it works. Because we're essentially saying, hey, if it's ever null, don't even continue. Only continue if there is a valid card details. So this is one way we can do it. Another way that you can do it is using a very strict typeguard or type predicate function, as we've done before. I'm going to show you this one as well. If valid card element, this is going to be equal to us receiving some card value. But what is the card value? Well, it's either going to be a Stripe card element, as we saw earlier when we checked inside of this card details, or it's going to be null. So to do that, we need to bring in Stripe card element. Now, Stripe card element actually doesn't even come from React Stripe.js. Inside the documentation, they actually say they bring it in from Stripe itself, the Stripe library. So here, let's just say that we get it from @stripe/stripe-js. It is a Stripe card element. And here, again, we'll cast this card either to Stripe card element or null. And what we'll say is that card is Stripe card element if it returns true. So how do we know for sure that this card must be a Stripe card element? Well, if the card is not equal to null, then this must be a Stripe card element. If it's not null, it can only be a Stripe card element. And now we can even get more explicit with our check, and we can say if this is invalid, meaning that it is not equal to a Stripe card element, then return. Otherwise, it must be a stripe card element, which is exactly what our type guard does. So 2 different ways you can do it. This one is more TypeScript friendly because it is a type guard. So we're going to do this one because it's more consistent with our code. And there we go. We have actually typed out the majority of what's challenging. My challenge to you is to type out the remaining of these components. You've already seen the majority of the patterns. You can now type the rest of these as a bit of practice. If you want even more practice, you can undo this and then type it all out yourself as well. In the end, what I'm going to give you is the actual URL link or the GitHub repo to all of these components being fully typed. Honestly, nothing else is going to be a total shocker, but you can read through it and make sure that your typing versus my typing is pretty much the same. But we had already done 50% of everything. And from this point forward now, we are going to use TypeScript inside of our projects. So I'll see you in the next video. Hello everyone, and welcome back. In this video, we are going to learn about GraphQL. GraphQL is a Facebook-created querying language which allows us to ask for data from our backend. Generally speaking, it's actually very simple when it comes to the actual top-level view of GraphQL. The part where it gets a little complicated is getting used to the syntax of GraphQL. But first, let's start with the high-level concept of how GraphQL works and then how your front-end will interact with a GraphQL backend. To begin, remember, we have our front-end and we have our backend server. And as we typically know, with most backends, they usually have these routes that are exposed that allow us to make requests to these routes or endpoints. Those are interchangeable terms. Where our front end will make a request to one of these endpoints, let's say to /products. And when we make this request, most likely a GET request, we will get back a response from that endpoint for a list of products. These products will usually come in the format that the backend has them stored in. So if there is an ID, if there is a name, then we'll get all of those properties. Now, if there's more, such as there is a price, there is a currency, then we still will get all of those fields. The backend stores the data. Generally speaking, when it sends back the response, it sends back whatever data the backend wants to send back. Maybe the backend will limit that data, maybe it won't. At the end of the day, the backend is what determines what is inside of that data that you are requesting. This is a very common pattern and has been around for as long as REST APIs have been a thing. This is where GraphQL is different. With GraphQL, instead of having multiple endpoints that you make requests for, there is just one endpoint, the GraphQL endpoint. And with this endpoint, your front end makes a request, but the request will take the form of an object. So technically, you can see it as a GraphQL object or you can see it as a query, but the whole idea is that the front end is going to send in the request a blob that has essentially all of the rules of what it wants from the GraphQL backend. So if we want to query some data, we will send a query request. And the query request will hold the shape of what looks like an object where we will define what we're looking for. Now, let's imagine that in our backend, we had this data set, which was known as collections. And the collections is just all of our products, which is pretty much in our Firebase what our categories is. So let's say we want the collections. We would define once again another object shape. And here you would put all of the keys that you want as part of your collections. So let's say we just want the ID and we want the title. What happens now is that GraphQL takes that request shape, that blob essentially, and it will send you back a response where those fields will be the fields in the objects that get sent back to you for what you're asking for. So if we're asking for all the collections and we just say, hey, I just want ID and title, then that's all you're going to get back. You're just going to get back a collection or an array of all of your collection objects, where each object is going to have just the ID and the title. Now, if we want to expand upon this, so let's say we made another request, but this time with the collections, we also want the items inside of it. Now, items is going to point to a different data table in the backend. All you need to know is that the item stores an additional data set where these items also have their own shape. Just as you might expect, we also need to define from the items what properties we want inside of the items. Let's say we want the ID, we want the name, and the price for each of these items. Once again, GraphQL will take that query blob and it will send back where all the collections will have ID, title, and items. But items will come back as an array where the inside values of each item will match the corresponding keys that we passed into the items portion. So we ask for ID, name, and price. We're going to get back ID, name, and price. So this is how GraphQL works. You can, in this sense, be the one on the front end that dictates what kind of data you want from the back end, what shape you want from it, how you want it. It's a lot more powerful for the front end in this manner. At the top level, once again, it's very simple. And for us to actually start interacting with this, we're going to need to actually practice writing inside of this query language because, again, it takes a little getting used to with the syntax. So let's do that in the next video where I have rebuilt the backend for us inside of GraphQL so we can start working with it. I'll see you in the next video. Welcome back, everyone. In this video, we are going to pick up our GraphQL lesson. So this repository inside of your resource folder contains a repo that I have made for you, which is branched off roughly from lesson 25, which is where we had just finished setting up everything for Netlify. The reason why we branched off from here is because there are a couple differences and nuances of GraphQL that we want to implement that directly correspond to what we do later. So GraphQL is actually a replacement for Redux. It's very rare that you will utilize both GraphQL and Redux. The reason being that GraphQL has its own way of keeping track of the data, and typically speaking, GraphQL data querying kind of runs in conflict with Redux. Now we'll discuss that more once we get to the actual implementation section. But inside of this repo, I want you to copy the repo, and then I want you to go to your actual application, and I want you to clone it down into a new folder. Make sure that you're not in your previous Crwn-Clothing folder. So you can just clone that down, and then just make sure you go into your new folder once you've finished it. Now, once you're inside of your repo, what I want you to do is I want you to yarn add in two packages. The first is at Apollo/client. Apollo is going to be a front-end client that allows us to make requests for GraphQL, as well as receive responses for GraphQL, and it comes with a bunch of bindings for React so that we can actually get GraphQL data and make GraphQL requests within our components. That's the first thing. The next thing I want you to add is the GraphQL library itself. So with these two different libraries, we are now going to be able to actually utilize it inside of our application. While all of this is installing, I want to talk about GraphQL and the syntax. So to do this, what we're going to do is go back to our web browser, and I want you to go into your resources folder and look for this GraphQL playground link. This will take you to Crwn-Clothing.com, where I have made this website for you, which is known as a GraphQL playground. A GraphQL playground is a place where you can make queries in the GraphQL language directly against the database or the GraphQL server that's connected to the database. GraphQL sits between the database and the server, and what it does is it allows you to format your requests in the manner that we discussed in the previous video, where we pass it some object that looks roughly like the data you want. Now let me show you what is inside of this playground. Over on this side here is where you will enter in the information that tells GraphQL what you want. So here you'll see write your query or mutation on line 1. A query is a request for data. A mutation is a request to modify or add data. That's mainly the two different things that you can do inside of GraphQL. It's all queries where you request data, and it's all mutations where you ask to update or create or delete data. So you can see these kind of like your REST API in a way. Down here is where you include any additional variables, which we'll discuss when we start talking about doing queries and mutations. Over here is where you will get a response. When you hit this play button, once you have a correct query or mutation, the data will show up here. This is also going to tell you if you have an incorrect query or mutation. Any response back is all going to happen here. There are also two additional tabs here. The first one I want to talk about is the schema. The schema represents everything that you can make inside of GraphQL. So we have queries, and queries define the different types of requests you can ask for. Remember, we have to tell GraphQL what we want. And the name of what you are asking for is actually defined by the person who wrote the server. So these queries I created. You'll see that I made 3 different queries for you. There is collections, where you get back an array of collections. Now, what is a collection? A collection you can see down here as the type. This is very similar to what we wrote in Typescript. Collection actually replaces category, as you know, inside of our main application. The category, of course, represents the collection of clothing, and inside of a category, there were category items. Here instead, I have called it a collection. And in a collection, there are items. So if you look at this definition signature of the type, you'll see that we have ID. So the ID is any identifier, but in GraphQL, there is capitalized ID to signify that this is specifically meant to be unique. It's in the format of a string, but it's also unique. That's why it is ID in caps. You'll also notice that there is this exclamation mark. The exclamation mark signifies that this field is mandatory. This is not an optional field. Without it, then it's optional. There is a title, which points to string. And the string similarly is also not optional. It is mandatory. Next, you will see items. Items points to an item type, meaning that this is going to hold a collection of items or an array of items. The array is designated by the square brackets, and inside will state what that type inside the array will be. So of course they are items, also necessary, and the array also necessary. So that's another thing. Coming down here, you will see the type of item. And here you will see again, identifier must be unique, hence the capital ID. Name of string, price of float. Float is a number. The only thing is that it can be decimal placed, which is why you will see float, also necessary. Image URL, which is a string, and then collection, a collection. And the reason why there is this is so that GraphQL can connect an item so that it belongs to a specific collection. It's really just the way that GraphQL sets up on the back end. Primarily, you will not usually be querying for this collection, but you can if you wanted to. If you were fetching an item and you wanted to know the collection it was in, you could also reference the collection. So this, again, defines for you what the types will be. And then as for the queries, we'll talk about that in the next video where we'll actually start querying GraphQL for some data. But for now, I just want you to know that if at any point you wanted to look at what your data that you can ask for looks like, because again, we're asking for very specific parts of the data, always open up the schema to see what you have. Okay, let's jump into the next video where we will start working with the queries. I'll see you in the next video. Welcome back, everyone. In this video, we are going to actually start working with queries. Now, queries, again, is when you ask GraphQL for some data. Inside, on the right hand here, the great thing about the playground is it will offer some autocomplete features, meaning that as you start typing, it will tell you what options are available to you. The format that we define our GraphQL always comes in the form of either asking for a mutation or a query. So to begin, when we're asking for data with a query, there are only the ones available to you inside of this section of query on your schema. because somebody who wrote the GraphQL server needs to define to you explicitly what you can ask for and how you can ask for it. So here, if you ask for collections, then it will give you back an array of collections. So I need to start by saying, I'm going to give you a query. And this query is going to request from you collections. Now, as you type, you will notice that GraphQL will give you hints, meaning that these are the only things that you can ask for. This is what you'll get back if you query, depending on the one that you ask for. Collection singular is asking for one collection, which we'll talk about after. Collections array gives you back all of the collections that match. And then get collection by title, you get back a single collection, but you have to tell it the title of the collection you're looking for. Now let's talk about the first one, collections, because I don't want to talk about variables yet before we even work with everything. Here, collections matches the one that you see here, but you saw this warning. Collections of type collection must have selection subfields. So this is telling us, hey, you can't ask for this query unless you tell me what subfields you want on this collection. What are the subfields? Well, those are going to be those keys on the actual type that I want to include. So to begin, let's say I want the ID, and I also want the title. So by typing it out like this, if I now make a request, I get back this object. So this is the structure. As I mentioned, it looks object-like, but there's no fields to it. It's just the keys. There's also no commas. So I'm saying, hey, give me a query on the collections query. And when you give me back the data, I want the ID and the title on that data. Now here, once we hit play, you'll see that this is a top level JSON object. So it's an object where inside it contains a field data that contains all of our data, again as an object. And inside is the name of our query. That name is going to correspond to an array which contains all of our different collections with an ID and also with the title. If I wanted more, let's say I wanted the items as well. You'll notice now that there's this little red signature on the side here because this again represents that there's an error that we have. And similarly to what we had before, I have to give it a subfield, meaning that if I'm asking for items, what are the fields I want from the items? Now, from the items, again, we can open up the schema. And let's say that for now, I just want the name because I need this schema in order for me to reference. It's hard to remember what everything will be. So always jump between the schema and your actual query. And let's say I just want the name from the items. Now, if I rerun my request, for each of my collections, I get back the array on the items where I just have the name. If I also wanted the ID and I also wanted the price, I can easily add those in. And once again, I get back my values. Checking the schema, are there any other values that I might want? There might be the image URL. So again, it's very easy to forget what kind of values you have on your data. And always, always use the playground when you're composing and writing out your queries and your mutations or anything inside of GraphQL. Because when you're trying to do it inside your application, you're not going to have the schema. You're not going to be able to test out your calls. That's the beautiful thing about the playground, is that this is essentially where you build out your asks from GraphQL. So far, our query has been made to all of the collections. But we can also, when you look at my schema here, you'll notice that I created another query for you where you can get back a singular collection. Looking at this signature, you can assume that because I'm asking for an ID, you're going to get back a singular collection that matches that ID. So let's test out this new query. First of all, looking at the signature, you can tell that I'm asking you for what looks like a parameter of ID that must be of the ID type. And it's necessary that you give me that ID, hence the exclamation mark. So how do we write this out? Well, first off, in order to get the ID, we have to pass this in as a variable. And as I mentioned down here, you'll notice that it says query variables. So in order to pass it a variable, you pass it as a JSON object. So there's an outer object. And what do we need? We need an ID. So here you're just going to state this is an ID. And the ID value that we're going to give it is going to be of one of these IDs. So I want to use this one for the hats. So I'm going to copy this top level ID for the collection. Make sure you don't get one for the item. And then we're going to pass it as a string. And now when you hover over it, it says variable ID does not appear in any GraphQL query. So again, the playground is trying to help us. It's true, we have not actually used this variable inside our query. So to do this, let's go back into our schema so that we can understand how to build out this query. To begin with, at this top level, any of these variables you want to pass at that top query level to tell it these are going to be the variables that are referenced inside of the query. To begin with, you are going to put a $sign for all of these parameters. So for us, we only have one parameter, so it's going to be $ID, and then you're going to tell it the type. The type is going to be an ID, like this. And now, if you hover over it, there's another error. It says variable ID is not used. So this is where you define the entry point for your variables. Down here is where you define the usage of those variables inside of the actual specific query you're making. Because again, right now the query thinks that we're still trying to make a collection query. If I call this one collection, I can now open this up, pass it an ID parameter, and then I'm going to put colon to tell it which variable to use. And the variable is $ID. Now here you'll notice that we are still getting an error. If you hover over it, it says variable $ID of type ID used in position expecting ID exclamation. The reason for this is because GraphQL inside of this query, we're saying that this ID you must receive, meaning that there must be a matching variable being passed in. So this cannot be optional. So you have to similarly make sure that you identify that this type for this ID variable is also mandatory. And now you'll see the error go away. So again, the query top level is where you identify, I am going to give you some parameter from a variable, which is down here. Once it's inside, it has this type. And this ID you can now use similarly inside of your corresponding query so that you can pass that value into it. And here you will now see that when we make this request, we get back just a singular collection. Again, we still have the same shape. There is a data, and then there is a collection key. And on the collection key is the JSON object of our matching ID, which was the hats collection with all of the same items because we've kept the same shape. Now, one thing I do want to mention is that the reason why on the data, this is under this key collection is because technically speaking, you can make multiple requests. We're only requesting one collection here, but we can actually request for multiple collections or completely different queries altogether. We can make that same request we had earlier for collections, and inside of collections, we can actually copy the exact same structure that we had for our data. This is a valid query. If you ask for it now, you'll notice that still we have our data. We have the collection that we asked for up here. But if you reduce this, notice that we're also now getting all of our collections. So just something that I wanted to point out. But here we have both of our queries. So now that we know how to play around with the GraphQL library, you can go free and try out the playground yourself. Make some requests, see how it works, look at the structure, because this structure is going to be identical to the ones that we need to make inside of our React application. And now that all of our libraries are finished installing, let's go back in the next video and actually work with the library. I'll see you in the next video. Welcome back, everyone. So make sure you are inside of the new GraphQL version of the application. Make sure all of the libraries are installed. And to begin, in order to start working with GraphQL, we need to first, as you might suspect, wrap the application in some kind of GraphQL provider. Now, instead of a GraphQL provider, it's actually going to be an Apollo provider. So in order to get started with that, we need to import in a few things. The first is going to be this Apollo client. Now, Apollo client is going to be the thing that registers the actual GraphQL server that you're trying to hit. So we need the Apollo client. The next thing we need is something known as in-memory cache. And we also need the Apollo provider. So this, of course, being the provider that you wrap around your application. To begin with, the first thing we need to do is initialize the client. So we'll say const client is equal to a new Apollo client. And we're going to pass into this Apollo client a single parameter, which is going to be an object. The object is going to have URI as a key, where you will point to the URL of the server. Now, the URL of the server is going to be our GraphQL playground, which is also our server's entry point. They serve double duty. So this, you can just come back to the actual URL, copy it, and then paste it in. As for the actual cache, this is the second key value. So remember, we were looking at that in-memory cache, which we imported. We're going to say new in-memory cache. And what caching does is exactly as you might expect with any type of caching. When you make a request with GraphQL, that request comes back and GraphQL will actually cache that value as well. So if you make that request again, if nothing's changed, GraphQL will just give you the cached value. And this is where it's really handy because essentially there is a local copy of the data you have asked for. So that's the big thing with Apollo that you can do. So once we have set up this client, what we want to do now is we want to wrap the highest part of our application inside of this Apollo provider. Now we're going to wrap all of our code inside of our new Apollo provider, and we're going to pass to it client, where the client is going to go to this new Apollo client that we created. And now we're able to utilize GraphQL inside of our application. So the first place to start is I'm going to work with our categories context, because if you remember, that's where we're actually fetching our data. So if you open up the categories context, instead of actually making this request to Firebase, we now have our own separate server that is hosting our data. So what I'm going to do is I'm just going to quickly get rid of this code so that we have a better idea of what's going on. Now, the first thing that I want to do is I want to import in two different things from the Apollo client. I want to import in GQL. GQL is what allows us to write those same query signatures that we have been doing inside of the playground. The next thing I want is useQuery, because useQuery is how we'll actually be able to utilize the actual shape that we made and make a request. So exactly as it looks like, you use query when you want to make a query. Now what I'm going to do is I'm going to define that shape of the object. So I'm going to say const collections, and I can say this in capitals like this, is equal to GQL. And then we pass it a string interpolation. So the backticks, remember to use backticks, not single quotes or double quotes. Inside of here, I'm going to say query collections, or I can actually call it get collections if I want to be more explicit. And what I'm going to say inside of this query is that, okay, there's collections, which is the name of the query, and then there's the fields. So here we can come to the playground and we can just copy this over. Like so. And now this represents our collections query. You don't even need this title. It's more so for yourself if you want to read it. But I'm just going to get rid of it just so that our signature matches what we've already currently seen inside of our GraphQL playground. But this now represents the tag. You'll notice it looks pretty much the exact same as what we had inside of our previous playground. So here, once I have this all set up, what I'm also going to do, other than fixing these indents so that they're more in line with what I want to see, is now I am going to actually use this inside of the provider. So the first thing I'm going to do is I'm going to call that use query hook that we got back. And what it returns back to us, I'm going to discuss. But first, I'm going to pass this collections query that we just made into use query. So again, remember, you want to make a GraphQL query inside of the shape that you want. You just pass it using the GQL tag with this backtick string, and then you literally just paste it exactly as you see. Here, inside of calling this use query, this will give us back three things. It'll give us back a Boolean telling us if this is being loaded. Just like we did with our Redux-Saga and Redux-Thunk videos where we had some kind of loading state, use query also gives us a loading state. It gives us also an error in case you have an error get thrown, and you also get back the data. So here, what I'm going to do is I'm just going to console log out the data so we can see what we're working with. So if we save this, and let's go back to our terminal and make sure that we start our server. And now if we come to our application and we restart, we should see the request get made to GraphQL. And there we see it. We see that we have first initially undefined when the query first goes out. So when we initialize our application, of course, there is no data because the query is still being created. Then once it's done, you'll notice that we get back the data and it matches the shape what was in our playground. So we see our collections, and inside of our collections, we have the array with all of the values that we have asked for. So this is pretty much what we need to work with GraphQL. This is our data. We just have to get used to this structure when it comes to destructuring it off inside of our application. Now, in order for us to double check a couple things, let me just also make sure that I console log the loading state. So here what I'm going to do is I'm going to console log out loading as a string points to the loading value. And similarly, data is the data. So now we get to see all the different states as this hook works. First, we see we initialize loading is true, data is undefined, then loading is false, and data is equal to the collections. So very intuitive. We understand how it works. On mount, of course, default state of loading is going to be true because the query is being made. Data is undefined because we have no data. Loading is false because we've gotten back our data. And of course, then we see our data object. So there we go. Now that we have our data, let's start modifying our context so that we can now use what we're getting back. We'll do that in the next video together. Welcome back, everyone. In this video, we are going to learn how to work with the data that we fetched in the last video. So as we saw, this use query hook, along with our collections GQL query, was able to return back to us the data of collections. What we want to do now is we want to convert it from the array of collections over to this map of collections that we're so used to using. So in order for us to utilize this, what we'll do is we'll transform the data. And to transform the data, we'll run an effect. As you can imagine, the data that we get back from this hook is something that we can pass into our useEffects dependency array so that we only run this effect whenever the data updates. So we know that whenever we get this data, we want to essentially reduce over it and generate the map as we've been doing up to this point. What we want to do though is we want to make sure that that data exists first, because as we saw on initialization, that data comes in undefined when we're initially fetching for that data. So here we'll say if the data exists, then what we'll do is we will fetch the collections value off of the data. Next, what we're going to do is we need to generate this collections map. So this is equal to the same code we had before, where we reduced over it, and we start with an object. As we reduce over it, what we're going to do is in the callback, we know that we're getting this accumulator value as well as the collection itself. So we'll say, first, let's pull off the title and the items from the collection. And then we'll add that title as the key onto the accumulator, and we'll make sure that we lowercase it as well. And this value will be set to the items array. And then we just need to return the accumulator so that it continues on through the rest of the reduce. Once we're done, then we are going to set the categories map equal to our collections map. So we'll run set categories map equal to collections map. And that's it. That's all we need. We can now get rid of our console log. And now categories map is already passed as a value into our context. But we can also add in the loading state, like so. And now we have all of our values. If we go back to our application, what we'll see is that if we enter the shop, our data is present. If we go into a category, the data is still there. So everything works. We have everything hooked up. But one thing that we might want to do is that on refresh, notice that we don't have the spinner because we had that when we implemented our Redux-Saga as well as our Redux-Thunk pattern. But due to the fact that loading is present now, we can always leverage this inside of our appropriate application. So here I'm going to go into the category component. Actually, let's go into the shop component. So in the shop component, we know that we have categories preview and category. In the categories preview is where we draw the categories map. So in order for us to modify this to use the spinner and the loading value, we're already passing that loading value through the actual context. So we can just get that directly here now. Next, what we're going to do is we want to import in the spinner component. So let's import spinner from our components folder, our spinner folder, spinner component. And now all we need to do is conditionally render. So we will say, if it's loading, then render the spinner component. Otherwise, render in our object keys map code that we had up until this point. So now if we save this and we go back to our application and we do a hard refresh, there we see our spinner and then our code loads in. Awesome. So let's do the same thing for our other component, which is our category component. So opening up this component, we're going to do the same thing. We're going to bring in the loading value, and we're also going to import in our spinner. Going up to our components folder, into our spinner folder, grabbing our spinner component. So just like we did before, here what we're going to do is we are going to wrap this fragment inside of a conditional check. So we'll say that if loading is true, then load the spinner. Otherwise, render out this title and this category container. But because this needs a top-level parent, we'll also wrap this inside of a fragment. And I'm sure that some of my spacing is off or my brackets, like so. And there we go. So let's save this and let's go back into our category preview. And if we refresh, we see where our spinner, and then we see our content. Awesome. So everything here is working. So we've learned how to use that exact same collections query that we had in our GraphQL in order to fetch all of the appropriate items. In the next video, let's actually leverage a different query and query by a variable. And I'll show you how that works. I'll see you in the next video. Welcome back, everyone. In the last video, we learned how to utilize our collections query. In this video, I'm going to show you how to use a different query where you can pass it a variable inside of our code. Now, we've already seen our collection query by ID, but inside of our application, there's a chance that we don't actually have the ID. What we do have is a URL parameter that contains the actual title that we can also query by. And you'll notice that I made you this method, getCollectionsByTitle. So I know it says collections plural, but really it's singular when you look at the definition. It's a single collection. And what you pass to it is a title string. So the title is what has to match. So in order for us to use this new method, first of all, we're going to update our variable from ID to title. And then the actual value will use hats, which we know is a working title. Then what we'll do is update the actual variable in the query to title. And from an ID, it goes to a string. Then it's just a matter of updating this collection from title to our title variable. And then instead of collection, we need getCollectionsByTitle as the actual method. And now once we have this, we can fire this off. And we'll notice that we get the appropriate data, but it's mapped under this getCollectionsByTitle. The key thing though that we want is really this query. So what we're going to do is take this query in order to understand how it is that it works. So let's go back to our application. Inside of our category code, we know that we have access to the title through the parameter category. So we want to utilize this category parameter as the variable that we pass in when we fetch for collection by title. Now, how do we do this? So first off, we're going to still need to leverage useQuery and GQL. So let's bring in the appropriate library. So it's at Apollo client. And here directly inside of this component, we can use GQL as well as use query. So essentially by the independent component, we are not using the context anymore in order to fetch this value. So first what I'm going to do is I'm actually going to get rid of this use context just so that we know what's happening inside of our code. I'm just going to remove this so that we know we have to replace all of this code anyways. And I'm just going to remove the use context. So all we have so far is just the category, which we know is a string of the title that we need to update. Next, what we're going to do is we are going to first initialize in the use query. We're not going to talk about what we're going to do yet. We just need to make sure that we know the signature. So we know that we're passing into the use query some kind of GraphQL blob object. So here I am going to say const get category is equal to GQL and then the backticks. And inside, I'm just going to paste the full query blob that we had copied from our GraphQL playground. Now what we're going to do is pass that into useQuery. And in order to pass a variable in for title, we actually pass a second parameter to useQuery. And this is going to be a configuration object. Inside the object, you want to tell it with the key variables what the different variables that this blob can expect to see will be. So that will be another object. Now it's just a matter of passing the actual values into the query right here. So we can say that the variable that we're passing in is title. What is the title? Well, it's the category value. And then what do we get back from this query? Just like before, we'll get a loading state, any potential errors, as well as the data. And for now, what we'll do is we can just actually log out the values. So here, what I'm going to show you is I'm going to replace that with an empty array so that our code actually passes. And then I'm just going to console log out the data so we can see the shape. So let's save this. Let's go back into our application. And now we saw it. We got undefined. And then we get the object where the query is the actual name under which our data is nested. So here, going back inside of our code, we need to modify this data so that we can get the products, which is what we'll map through. In order to do that, we can say directly inside of a use effect, because we want to run a use effect whenever we want to modify our data. And we'll run it every time category changes and every time the data changes. And here we'll say if data, because as we know, data can be undefined, we're going to pluck off the get collections by title key, which is the name of our query. And off of this is going to be the full category. We only need the actual value. So here what we're going to say is that the items is what we want. These items are going to all be nested on this data object. And then it's just a matter of running set products on the items. So we're doing a nested destructure here. We're saying first destructure, get collections by title, and then off of this object, I want you to destructure off items. So it's a nested destructure in order for us to set up our flow of data. And now, if we save our code, we once again go back. Let's refresh. We see our loading spinner, and then we see our appropriate data. So that's it. The main key challenge in using this use query is just understanding that when you want to pass in these variables, it has to be passed into the use query hook. You're going to have to use some kind of configuration object under which you pass the variables as an object, where you then match the appropriate values to the appropriate parameters inside of your query. One of the advantages of using this independent query style, and as I mentioned before, that with GraphQL and Apollo, you actually replace Redux. The reason why is when we start looking at our fetch calls. And I mentioned earlier that there are caching that is happening under the hood. So let's look at our network tab and refresh. We see a bunch of requests for different files. The bundle here is the bundle of all of our JavaScript code. The CSS is all of our CSS relevant for this page. I want you to look down here though at this Crwn-Clothing one. The reason why I want you to focus on this one is because this is actually the call to our GraphQL servers URL. If you click on this, you'll notice that inside of headers, there's a couple with request options. The request options one, you don't have to worry about. It's mainly the post request one that is important, because if you look at the payload, we're getting back the actual value. So this is literally showing us our initial query and what we'll receive back from GraphQL server for the actual JSON payload. So this is the request itself. You'll notice though that we also have all of these different favicons and PNGs. The PNGs are the actual literal images. Remember that we pass them as strings, and then once React loads, it fetches the image from the respective URL passed. But now what I want you to notice is that if I navigate away, I want you to ignore all these other calls. Those are not important. If we go back to hats, you see that the only thing that we refetch is the images. We don't make another call to the Crwn-Clothing GraphQL server. The reason for that is because this query for this page has already been cached. GraphQL and Apollo know that we don't need to refetch this. I've already stored it. And the reason I don't need to refetch this is because the variables in the query hasn't changed. You're just giving me hats again. But if we go to jackets, there we see we make a new request. So again, the first one is the options. The second one is the actual request. And there in the payload, we see the actual values that we want. So you can imagine that if we go back to hats, notice how we just fetch the hat images, no GraphQL request. And similarly, we go back to jackets, again, just the images, not the actual GraphQL request. So again, we're just caching those values, and this makes our code much more performant. So if you were wondering earlier when we were on our hats and when we refreshed, why we saw that there were two sets of Crwn-Clothing fetch calls, now the reason for this is because our context is still fetching the full list of collections. So we're making one request for the full collections from our category context, And then we're making an independent call to get collections by title inside of our category component. Remember, both are mounting, so two requests are going through. But as a result, what I want you to realize is that GraphQL and Apollo are not caching by the actual items. They're caching by the query, which is why even though we're fetching the full collections, we're still making a separate fetch for the independent collection, even though that collection lives inside of the bigger collections as a whole. So this caching does not happen at the item level. Again, let's go to sneakers. We notice that we make a call. We know these sneakers do live inside of our larger collections call, but we still made a fetch. So again, what Apollo caches is the query, not the actual items themselves. So that's an important thing to remember. So now that we understand how GraphQL works now and how caching works now, you can actually pretty much use this as the basis for interacting with Apollo for the majority, 80-90% of what you're going to do inside of your actual Apollo project in GraphQL. In the next video, I'm going to tidy this up and we'll talk about why you would prioritize using GraphQL versus a normal REST API, and then some of the advantages, disadvantages, as well as other things you can do. So I'll see you in the next video. Welcome back, everyone. So in the last video, I showed you an independent query. I just want to mention that inside of this application, I did not create a mutation for you. The reason why is because, unfortunately, in order for me to show you the playground, I had to set up a backend playground from scratch. As a result, if I created a mutation for you, then anybody would be able to store data inside a mutation or make modifications. And as a result, the course and the actual server would become inconsistent for all the different students as everybody was making mutations. But I do want to talk about how the mutations work inside of Apollo. So again, the format is pretty much the exact same. Nothing is that different with mutations and query. And that's what's really nice about GraphQL and Apollo, is that there is a very streamlined syntax that you have to know in order for you to work with it. I'm going to show you, but we can't see it actually work live, again, because there's no mutations, but we can take a look at the syntax. So the way it works is you're going to bring in the use mutation hook. And then let's say that we were setting some kind of category. What you would say is, again, you would make a set category GQL blob. And then inside, what you would add is the actual mutation. So this would be the object that you want to add. And instead of saying query, you would say mutation. And then it's just a matter of adding the appropriate values. So for example, let's say in this particular case, this mutation was really just adding a new category item. You could literally say category, like so, goes to, and then the category type that we have inside of our GraphQL types. Then you would just call the literal mutation, add category. So this mutation name would be inside of our playground in the schema. So up here, you see type query. You would just see an additional one, type mutation. And then just like you saw here, it would just be a different signature. Instead of a get, it would be set. It's very similar. So you would just take that value of the actual mutation name. And just like we did, you would just pass the category calling the appropriate value. And then it's just a matter of saying what values you're trying to update inside of your store. So it could probably be the exact same as what we have here. And now, with this set category, in order for you to use it, what you would do is just say const, and then you would just pass in out of the actual array that you get back, the use mutation hook, giving it set category. Then it's just a matter of naming the actual function that you get back. So this is a mutating function because again, we're trying to pass it some data. So this would be add category. And then as you can imagine, the second argument is the same as what you get here. So you get a loading state, you're getting an error, and then you get the data. So let's actually hide this for now so that we can just see this work. And this add category function is just a function that expects to receive an object where you pass it the variables. And then it's just a matter of matching the variable category, like so, to some category object that we're trying to store. So this object, of course, would be the literal object. And that's it. This will now generate the mutation for you. And then you'll see it inside of your actual backend if you were looking at your database. But also the data would come back. The loading values would change as it's loading the actual process of setting the value. If it's successfully set, it comes back with the data. And that's it. This is all the mutation is. So again, the signature is very similar. You're just really switching from mutation to query and from query to mutation. But everything else about the GraphQL querying language is very streamlined. So once you've learned it, you really now understand the majority of how to interact with GraphQL. Everything else is really just a matter of tweaking and playing with Apollo so that you might get a couple other additional features that might be helpful for you. One of them being the fact that, as we know, inside of our index.js, we are using the in-memory cache. There are some other caching options, but the in-memory cache is 95% of the time the one that you want, because it's really just caching what's on that person who's using your application's local computer or local browser, essentially. So it's using their memory to cache those values for that session that they're active for. But that's it. I know, unfortunately, I have not created a mutation for you, but again, the limitation is that this course is being accessed by thousands upon thousands of students at any given time. If I were to open up these mutations, then the backend becomes inconsistent, and I don't want that. But again, the signature is very similar, and that's mutations. So now that we understand mutations, let's finish up understanding GraphQL versus other versions of non-GraphQL applications. I'll see you in the next video. Welcome back, everyone. So now that we've understood how to work with Apollo and GraphQL, let's talk about the advantages and disadvantages and why you as a developer or as a team may want a GraphQL and Apollo React application versus a Redux React application. So first off, let me address Redux versus GraphQL and Apollo. Apollo seeks to act as a single source of truth for the data and state on your application. The same way that Redux does, where essentially the whole idea is that all of your application state of the data that you're fetching is stored in Redux. As we noticed with the caching and the actual fetching, this is exactly what Apollo is trying to do as well. As a result, an application that uses Apollo does not need Redux. When it comes to more minutia details, such as what we did with context, you can still keep context and utilize context in order to make some of these storage options, or in order to utilize context as a mounter to make the initial call in the first place at the top level. All of these patterns are still possible when it comes to coordinating the actual fetches and when the state gets stored and etc. But the actual single source of truth, Apollo is now the single source of truth, not Redux anymore. So as a result, what are those advantages and disadvantages? Well, one big thing about Apollo and GraphQL is that in order for you on the front end to use GraphQL, your backend must be set up similarly to spit out GraphQL. It must support GraphQL. And that requires a lot of work in order to set up all of these queries and all of these type definitions and everything in between as well. There's a lot of code to update on a server in order for it to be a GraphQL server. So unless your company and your backend teams are familiar and willing to navigate through the complexity of upgrading to GraphQL, it is not just something you can implement on the front end. And that's very important. Notice how we keep referencing back to the GraphQL playground in order to understand what we're fetching, how we're fetching it, and what the shape looks like. The advantage of this is that it becomes much more transparent to us on the front end. But the disadvantage is that this requires a constant coordination of the backend team in order to set up the backend to give us all of these benefits and perks. So that's not just something that we can decide to do exclusively on the front end. We have to get the backend teams on board as well, and they have to learn how to write in the GraphQL language. They have to understand the complexities of performance and how to improve it all on the server side. All we need to learn is just Apollo client. But other than that, for us, it's actually not that complicated. The large bulk of the complexity actually lives in the backend of setting up GraphQL servers. So that's one big disadvantage. The other one, of course, is that we have to get familiar with writing these GraphQL queries. While working with it, it seems rather intuitive, and it's designed to be. Apollo has actually come a very long way throughout the years. Before, it was way more complicated, and it was almost like writing backend GraphQL code on the front end. But now it's essentially all been isolated and extrapolated and hidden away from us, so that all we're really passing are just queries. And then, are you trying to make a query? Use the useQuery hook. Are you trying to use a mutation? Use the mutation hook. It's very flowed well now with the React ecosystem. But still, you do need to learn how to use this pattern, and it is different from web development anywhere else. So that's another thing, is that there is an additional learning curve, and a lot of different developers are very comfortable with the Flux architecture pattern that Redux has come from. Redux has also been scaled enormously across numerous applications. GraphQL has as well. It's come a long way, and so has Apollo. In fact, React is almost designed to work with GraphQL because Facebook also created GraphQL. Facebook created React, Facebook created GraphQL. So in turn, there is a lot of harmony in the way that they're designing both of these tools per se. But once again, a lot of the time, it comes down to the team, and it comes down to the scalability of the team, not necessarily the technology, but are there enough developers who are more comfortable with the Redux architecture at scale, or are they comfortable with GraphQL? So those are additional considerations that go beyond just the technology that a good developer must think about before jumping on any new hot technology. But that's my piece. Hopefully now you understand some of the discussions around GraphQL versus Redux, and also when you want to use GraphQL yourself. If you want to use it in your own projects, feel free to do so. Just understand you'll have to learn the backend of GraphQL as well. But other than that, using it on the front end, as you can see, is very simple. So that wraps up our GraphQL section. Welcome back, everyone. In this video series, we are going to talk about performance optimization in React. Now, performance optimization in React is an interesting topic because a lot of people want to write code that is performant. In fact, that is the main goal for a lot of developers, is to make sure that not only is your application working, but it's very performant and provides a good user experience. But I do want to talk about a few things. The first thing being that you do not want to over-optimize your code when you start writing it. This is an incredibly important point that I want you to understand as a React developer. You only want to start improving the performance of your code or optimizing your code once you see there is a performance bottleneck. If you do not notice any slowdowns in your code, there is no reason to start optimizing ahead of time. The reason for this is because these optimizations have a cost. That is a very important thing to know. Optimizations are not free. There are trade-offs. When you optimize your code, you are essentially saying, I'm going to spend more time, not just your time, but the computer's processing and resourcing time to improve the performance of some part of my code so that later it's more efficient. A good example of this is when we think about our selectors. When you think about the fact that we're memoizing these selectors, this create selector call has a cost on the memory and it has a cost on the rendering time. When reselect is memoizing this selector, it's literally storing the output value in memory somewhere. And to do that storage, it also takes time. However, the reason why we think it's optimized is because we're going to make this selector call multiple times, and every time our component re-renders, we might actually end up calling the selector every single time. So if that's the case, then by memoizing this selector function, yes, the initial step might be a little bit slower, but in the long run, it's way faster because every subsequent call doesn't require us to redetermine what the value of that selector is. So there you can see already where the trade-off lies. We trade off in the beginning so that we get more optimized calls later on. So this is a very important thing I want to talk about. A lot of the patterns that we've been coding in and learning in throughout this course are designed already to give you very optimal code. The React library and the React team is constantly working fervently on figuring out how to make their application also more performant. So this is the thing you need to know about React's library. It's got a ton of stuff under the hood to try and optimize and get around a lot of these issues anyways. So knowing that, it's very crucial that you know moving throughout this video series that you only optimize when you see a performance problem. If there is no performance problem, do not optimize. Now, despite that, there are some tools that React has given us to optimize the code inside of these components. And we'll discuss that in the next video. So I'll see you there. Welcome back, everyone. In this video, we are going to talk about a couple performance optimization hooks that React has given us access to. The first one I want to talk about is use callback. And to understand use callback, we need to understand how function declarations inside of a functional component work by understanding how React treats functional components. As I mentioned before, whenever you render or re-render a functional component, React is going to go through line by line of this entire function every single time. Hooks by nature are more optimized for this process, but any variables you declare. So if we were to hard code a variable, let's say ABC, which equals a string ABC, whenever this component renders or re-renders and it hits line 20, React is reinitializing this variable with this string. Now, with variable casting, this is pretty performant. It's extremely minimal and has very little cost. But when you take something more complex, like casting a function, this is definitely more expensive. Even with anonymous functions inside the return call, React is reinitializing this function every single time, including our named variables as well. These are also being reinitialized every single time. And the reason why this is happening is because React doesn't know whether or not this is something that is brand new or it isn't brand new, because it doesn't know if any of the scoped variables inside are referencing new values. React just operates in a way where it just behaves like regular JavaScript. I see a function definition, I'm going to define and initialize the function. So for us, generally speaking, this is not that costly. So this harkens back to what I was saying last video. Do not over optimize your code if you don't need to. But let's say you're working on an application and you have hundreds of components that are rendering on the page, and each and every one of them is initializing a function every single time, and numerous of those are constantly re-rendering. In that case, these little performance bumps may improve your actual overall performance. So how does use callback work? Use callback is a hook that takes two parameters. The first is the actual callback that you want to memoize. And the second is a dependency array that determines when it's time to re-memoize this function. Now, when we talked about memoizing, we were talking about memoization with selectors. And the way that we memoized our selectors was that if the parameters do not change of that function, then you will always give you back the same output. That was memoization with selectors. Memoization in this context is that React is doing something similar. Essentially, this callback, it does not need to reinitialize. As long as this dependency array value does not change, then React will always give you back the same function. Not the return of the function, but the actual function itself. React is memoizing the function. React is not memoizing the output of the function. And that's a very key difference to remember. Because of the fact that React is memoizing this function, now React does not need to reinitialize this function every time it comes and hits line 20 on a render or a re-render. The only time it will is if any values inside the dependency array changes. Now here you'll notice that the dependency array mentions that you're missing a dependency, which is navigate. This is where it kind of talks more about understanding how React uses references to determine if this value is new. Inside of React, and most of the time with these third-party libraries that create hooks, when you think about this use navigate hook, it's giving us some function navigate that we can use to navigate to different parts of our application. Generally speaking, unless the structure of your application is constantly changing from a route level in a dynamic manner, this navigate is going to be the exact same reference, which means that every time React renders or re-renders this cart dropdown component and hits line 18, this navigate, it's automatically going to know, oh, this is the same value. I don't need to get a new one from use navigate. So as a result, navigate is never really changing. So you don't actually need to pass navigate into your dependency array on line 22. React doesn't know that though. Use effect or use callback most of the time, as we notice. We get a lot of these warnings, but they don't know that this reference is doing that. So as a result, React will give you a warning. There is a dependency that's inside that I'm not sure if it will or will not update. Maybe you'll get some errors if you don't include it. The problem with adding it, and it's not really a big problem, but it is a concern and why there's two camps on this. When you add this dependency, it kind of sends a mixed message that you can expect this callback to reinitialize this function and that navigate is something that does change or can change or most likely will change. But this is actually not true. Generally speaking, we don't expect navigate to ever change. So this is where two camps sit on this topic. Some people say add it. As long as you understand that navigate is something that doesn't change, there's no harm in adding it. Other people say that it makes your code a little bit miscommunicated. It's saying that you can anticipate navigate to change, which is why I'm even adding it in the dependency at all. I'm expecting something to change. So again, this is where really it depends on the team and the person that's coding out your code. But the main thing to understand here, at the very least, with use callback now, our function is memoized. We don't really need to add it to the dependency array. But now that we have this memoized function, we can now expect that this cost is not going to be there to reinitialize this function every time. But if you miss adding something to this dependency array, you may actually come with a couple bugs. And that's what we're going to talk about. And through talking about that, we'll also better understand what's actually happening with use callback. So join me in the next video where we'll discuss that. I'll see you there. Welcome back, everyone. In this video, we are going to discuss the use callback hook further. In order for us to do that, we're going to have to modify this a little bit. So in order for us to modify this component, I want to duplicate this button. And what I'm going to do is I'm just going to say that this button has the text update. What happens here is that we know our component will essentially rerun and re-render every time cart items updates. So we're going to rely on that in order to make sure that we understand when our functional component is being rerun. Inside of go to checkout handler, I'm going to change this function. And what I'm going to do is I want to log out some value that we store inside of use state. So I'm going to bring in the use state, and I'm just going to call this temp value. And I'm going to initialize it with the value A. What I'm going to do inside of this callback is just console log the temp value. And then what I'm going to do on this button is that whenever you click this button, I'm going to set temp to B. And that's all I'm going to do. Now, what's going to happen? Well, let's save our code and let's come back to our application. Here in application, what I want to do is click go to checkout. As we know, we are console logging out our temp value. Here, what's going to happen is that when I run this function and add a bunch of items, what's happening again is that our application is re-rendering. Not our application, but our component. Go to checkout, we'll still log A. Nothing changed there. If I hit update though, now I know that temp has been updated to B. But every time I click go to checkout, it's still logging A. And the reason for this, despite all of these changes, is because the function is memoized, meaning that the scope of all of the values inside of this function are all being kept and memoized. React doesn't know that it needs to update this because temp on the outside has changed. Even though we called septemp and React has re-rendered this component, every time in the re-render cycle, it sees this call and it says, oh, this is a memoized callback because it used the use callback hook. I don't need to reinitialize this function ever. The only way that that can happen is when you add that to the dependency array. Now, if we save this, and when we come back to the application, If we refresh, now on initialization, when I click the go to checkout, I get A. When I click update and then I click go to checkout, now notice that it says B. So this is an important error that you want to understand about your dependency array with useCallback. If you anticipate anything inside of this function that it needs to rely on in order to run the purpose of this actual function, make sure you include it inside of your dependency array. Because if you don't, then React simply just memoizes the value. And that is how this useCallback works. I hope now through this example, you get a better idea of what it is that's actually happening under the hood with this useCallback hook. So now let's just revert our code back. And now we have a good idea at the very least. You can now go through your application and you can wrap these inside of a useCallback if you want to, just to see and just to work with it to understand how to add things to the dependency array and get your code to work consistently. But it's very straightforward. The main idea is that you're memoizing the function, not the output of the function, but the function. So that's it. Now that we get that, let's move on to the next video. Welcome back, everyone. In this video, we are going to learn about another optimization hook called useMemo. The way that useMemo works is that it allows us to memoize the return value of a function, very similar to the way that we have already become familiar with inside of reselect. The only thing is that we are not passing parameters all the time inside of our functions in React. A lot of our functional components rely on outside variables, such as variables defined by the state or defined by the scope and the props. So as a result, useMemo is a little different. I have here created a function that makes it very easy for us to extend the time it takes for something to finish. So what I can quickly do is create some function, and all it does is it just console.logs the start, and it console.logs the end. But what it does is it inside will delay for 2 seconds. On top of that, what I also want to do is I want to set some value count. And I'm going to use a useState value here simply to do so. So here, instead of our go to checkout handler, this is just going to be some function that sets the count value equal to the current count value plus 1. What I want to do from this function is I want to return 100 plus the count. So essentially when this function fires, what it's going to do, it's going to log start, it's going to wait 2 seconds, it's going to log the end, and then inside of this func value is going to be restored 100 count. So we can actually even call it, let's call it 100 count, just to be even more explicit, or 100 count. I don't know if React doesn't like us using numbers inside of our variables. And here I'm just going to say that some const val is equal to us running 100 count every time this component re-renders. So again, this is a very computationally expensive function just to give us 100 plus the current count value. And then what I'm going to do is I'm just going to comment out all of our cart items and just simply render the value here. So if I save this, and if I go back to my application, and let's just refresh. So here, inside of our application, if I were to click Go to Checkout, what happens, count increases by 1, and we see the start, there's a delay, and then end, and then we finally see this number update. So what we're seeing is that there is a lot of delay because this is a computationally expensive calculation. But the problem with this is that if I add to cart, the component will re-render, count will not need to update, but in spite of that, as we know with our functions, there is a very expensive calculation that happens before finally the end starts and we saw this application unfreeze. Notice that when I click add to cart here, even though I've hovered off, we're still in a hover state inside our product cart because the application is frozen due to our delay. So despite the fact that our count value is not updating, our really expensive function is getting recalculated every time. Now, what useMemo does is it memoizes the value inside of this hook. So when we pass it this function callback, what will happen is that 100 count will initialize. useMemo will calculate the value inside of this function, and then it will memoize that value somewhere. So anytime you reference it, it will now be using that memoized value, unless whatever dependency you pass inside this dependency array changes. So now, let's say I added the 100 count. I'm not going to add the dependency array yet, but here if I save now, I come back to the application and I refresh. Let's see what happens. So on mount, of course, as I mentioned, start needs to actually run, end runs after the delay, so nothing has changed about the delay. But at the very least, now we have our value. But if I were to add these values, notice how it's not re-rendering our cart. We're also not stuck inside of that delay. So this is essentially what happens. Every time the component is re-rendering, React is going into that useMemo hook, and whenever it sees that line right here on line 30, and it knows, hey, I've already calculated this value before. I'm just going to give you back whatever you get back from this value. And now I'm always going to get back that initial value. The problem, of course, as we can see, is that even though we're increasing the count, this number is not changing. So this is where you want to add in the dependency array for useMemo any of the variables that you want to track, so that essentially whenever that variable changes, React will recalculate the output of this very expensive function and then cache that value. So now, if we go back to our application, we see our initialization is slow. We have our 100. We hit go checkout, again, delay, and then the end, and then finally the value updates. But at the very least, it does not block whenever this component re-renders. The only time it's blocking and it needs to recompute our expensive function is when the actual dependency array values change. And that's it. This is how useMemo works. It's primarily for when you have expensive functions that need to recompute, and they depend on these values inside of your functional component. If you want to memorize those values and make sure that they don't get interrupted or they don't get rerun unnecessarily during a re-render cycle, then you use the useMemo hook. So that's the difference between useMemo and useCallback. useCallback memoizes the function itself. useMemo memoizes the return value of the function. So now we understand useMemo and useCallback. Welcome back, everyone. In this video, we are going to learn how inside of our rendering cycles, we may actually be getting extra renders that we do not need in order to better optimize our application. So inside of your resources folder, I want you to download this Chrome extension, the React Developer Tools offered by Facebook, which is also now named Meta. Once you've installed it, if you come back to your application, what I'm going to do is I'm going to reset our cart. So I'm going to remove everything from the cart. And then what I'm going to do is go into the shop page, and I am going to open up the developer console inside of its own window. Inside of here, what I want to do is I'm going to click these arrows, and you're going to see these two new little tabs added, one for components, one for the profiler. We want to focus on the profiler. The profiler allows us to record any interactions that happen inside of React, and this will pick it up. So first what I'm going to do is I'm going to start profiling, and then what I'll do is I will add some cart. So I'll add 1, 2, 3 of the brown brim hat, 1, 2, 3, 4, 5 of the blue beanie, and then 1 of the brown cowboy hat. Now if I come back and I stop profiling, what you'll see is this flame graph that will display, where it will show all of the different components and their interactions during this time. I want to zero in though right here on the cart dropdown component. So in here, there is a timeline that is showing all of the different things that are happening inside of our components. But inside the cart dropdown, what you'll see is the breakdown. You'll notice that we have our style div, which is our container, and then deeper inside, there will be additional components. This one right here, This component is actually our cart content because its sibling is the button. So if you remember inside of our checkout, there is a container here that holds all of our cart items, and then there is a button. So for us, inside of this container right here is the different cart items that we have. So depending on your timeline, if you click through it, you will see there will be more cart items added. And there will be different interactions that happen during this time. What's happening on this cart item is that this cart item has a render at each of these interactions. Now, what you'll notice is that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 interactions. There are 9 render interactions because even though we added 9 items, each time we add an item, this whole list is getting re-rendered. The reason it gets re-rendered is due to the fact that inside of our cart dropdown component, we are updating cart items. Cart items inside of select cart items is giving us a new array back. And React is re-rendering through the map every single cart item. As a result, React does not know that this cart item doesn't need to re-render. Luckily for us, due to the fact that with React, it is smart enough to know that the key value is being tracked and therefore it doesn't have to do all of the re-rendering process, but it is still wasting extra re-renders. As we can see, we added 9 hats, but each hat is also getting re-rendered 9 times, especially the first hat. That first hat that got added in that component is getting re-rendered all 9 times. So we don't want that. In order for us to improve it, we can actually bring in this memo method that React gives us. And what we do is we wrap it around our functional component. And as you can guess, with all memoization that we've learned up until this point, unless the actual value changes, then we don't need to re-render this component. So now, if we come back to the application, and what we want to do, we want to clear out our profiler. Let's refresh everything. Once it loads in, I'm also going to make sure to clear out the checkout. And now when we come back to our shop, what I'm going to do, I'm going to start profiling. And again, I'm going to add 3 of the brown brim hat, 5 of the blue beanie, and 1 of the brown cowboy. And now if we go back and we start profiling, now what we'll do, we already see inside a cart dropdown that once we narrow down, so again, top level container, cart items container, and this one right here, this is our brown brim hat, the first item. If we click on it, notice now how there's only 3 renders. The reason for that is because when the actual cart item changes, brown brim hat, of course, needs to re-render. The quantity is updating. But now React is smart enough to know that it does not need to re-render this component later on when those other components were added. In fact, if we go back up here and we check later inside of the time cycle, notice how this is when the second cart item got introduced. So of course there was the first cart item, the second cart item, then the third cart item. These are all, of course, brown brim hat. But the fourth item is when we added in that beanie. So this is the first time the beanie shows up. And notice how there are 5 renders because we added 5 beanies. But if we go up, what you'll notice is that at this instance, when we've moved on to this 4th event, this is our cart item. It did not need to render. It even says did not render. So this is how we explicitly know through that memoization now we are not unnecessarily additionally rendering our components. So this is one of the advantages. And using this profiler, you are now able to also profile throughout your application and try and see if there are any places where you need additional optimizations. And combined with this memoization tool, it allows us to properly update the appropriate components and re-render the appropriate ones we want to target only when they need to be updated. So this is a really handy tool. You pretty much just need Memo and the profiler. Check around the application, click around, profile some events, read through some of the components, see if there's anything that really needs optimizing. The only other place where this might happen is inside of the checkout component, because as we know inside of checkout, we do also map through the actual cart items for the checkout. So here with the checkout, We could also just simply wrap this inside of a memo. And I'm going to leave it to you to profile it yourself first before wrapping the memo to see what happens inside of your code base. And just double check to see, as you clear items, as you increase the items, as you remove the items, what is the profiler telling you? Then once you memoize it, what is the profiler telling you afterwards? Get comfortable with the profiler. It's a pretty handy tool. But again, always remember, do not over-optimize until you need to. If you sift through the profiler, you might even see that some of the initial times between memoizing and not memoizing may increase. Again, because the memoization cost is there. So there we go. Now that we understand how to optimize, profile, and memoize our functional components, let's move on to the next video. Welcome back, everyone. In this video, I want to talk about code splitting and chunking, React Lazy, as well as React Suspense. These are all things that you may have heard in rather recent versions of React, and when you're curious about what they are, they're really just ways that we can optimize the way that our browser downloads the code that we are serving from our website. If you were to look inside of your network tab, I just recently refreshed the website on the homepage, and I want to show you what you see here. So I'm going to remove some of these handles. A lot of what you see here, there are images, there are some different code blocks, some of them being from our Stripe library, some of them being from our own application. But the main thing that you'll really notice is that there is this CSS, which comes from Google API, which is, of course, our Google fonts. We have this bundle.js, which gives us the big bundle of all of our application code. And then there is a bunch of Stripe-related code and some font-related code related to Typescript for fonts. There's essentially a lot of different library code. The key thing is the bundle.js. The bundle.js is a bundle of all of our JavaScript. If I were to clear this out and navigate to different parts of the application, all of these calls that you see here, these are all for Firestore. This one is for Stripe. These are all images. This one again, Stripe, and this one Firestore. Nothing is being called from our application. If I clear this again and go to the authentication page, we see that there's no downloads. Again, other than a Stripe one. Stripe does its own thing. It's not really important for us. What this means is that when we come to our application for the first time, we are downloading the entire bundle of our application right out the gate. This is very inefficient because as we scale our application, our JavaScript code is going to get rather large, which means the load time it takes to download the entire bundle of our entire application is going to be costly. Why is it that when I'm on the home page, I want to download all of the JavaScript and React code for the sign-in page or for the shop page or even for the checkout page? None of those are important to me right now. The only thing that I should need is just the home page. And this is the whole idea of code splitting. By code splitting, we tell React and Webpack to split up our bundle into the appropriate quantities. Meaning that if I land on the home page, just give me the home page stuff. If I land on the shop page, just give me the shop page stuff. If I land on authentication, then give me authentication. So that is what we're going to do. We're going to use a combination of React Router as well as React in order to split our code at the route level. To do this, we need to use a couple new concepts. The first of which is that we are going to be using React Lazy as well as React Suspense. Both of these are required in order for us to do something known as dynamic imports. Dynamic imports is something that comes from modern JavaScript. It's a modern JavaScript feature. When you do an import like this is a synchronous import, meaning that your JavaScript code is not going to run until all of these imports are successfully brought into this file. Then it proceeds and actually renders and runs the rest of the JavaScript code. With a dynamic import, it's kind of like an async await. The way it's written, if we were to take this home component, for example, and turn it into a dynamic import, you would say const home is equal to await. And then inside of the await, or actually after the await, you would say import and then the route that you are importing. Like so. That's how we go from this style of import over to dynamic import. But the problem is that inside of React doesn't actually know how to utilize this. You need to use a combination of React Lazy and React Suspense in order for this to render. So how do we convert this over to React Lazy? So the way that you would utilize React Lazy is that instead of writing the await statement, lazy is actually its own function. It will return you back a modified version of this component when it receives it. So what you pass to lazy is a function with the import statement. And now this is a lazy component. Essentially, React will not render this until it actually fetches it when it's required. When is it required? Well, on the page that actually renders and it sees that this is a lazy import is when in the browser, the moment it encounters this, it's going to start requesting for this component from our server that is hosting all of our code. Unfortunately, in order to use it, we need to use React Suspense, because Suspense is essentially saying, hey, I know that you are currently trying to fetch something in suspended animation, meaning it's asynchronous, some component. While you're waiting, what do you want me to do? What do you want me to render? So here, what we can say is that, okay, if one of our routes or any of our code inside of this is being lazily loaded, then what we're going to do is instead show the spinner component. So here, let's import in spinner from our components, our spinner, and then our spinner component. And then for suspense, all we say is that, okay, suspense takes one value, which is the fallback. And the fallback is where you render the component you want to show when things are loading. So now if we save this and we come back to the application and let's refresh, you see the spinner and then you see everything load. But what you notice inside of this code, let me filter this down to JavaScript only. We have this new additional source routes home, which is coming from our website. And that is what is happening. When you land on the home page is when it actually tries to fetch the home component. If you are on the shop page, and let's say you re-rendered the entire application from scratch, notice how we're not pulling anything related to the home page. We get the bundle.js, of course, which is the appropriate bundle of the relevant code. But if we come now to the home page, there we see we actually finally then download the home component. So now it's very easy because at the route level, we can now very quickly wrap the appropriate route components inside of a lazy check. So now I'm going to say const authentication is equal to lazy import of this route. And now I can get rid of authentication. And if I save now, and I come back to my application, and I force a refresh, initially on the home page, we download our initial bundle, as well as our home component, because that's what we need. But when we go to sign in, is when we download our authentication. Notice that the bundle is 740 kilobytes. What I want to show you is that as we start splitting out this bundle, this size should theoretically get smaller because the initial bundle should grow smaller. So let's go back and let's start converting any of these relevant route components over to using our splitting. So I'm going to do the navigation component as well. In fact, let's just do these three right here. We need the spinner to be synchronously loaded because that is our only fallback component. So this one very clearly doesn't need to be a dynamic import. But these other ones like navigation, lazy, import, and then copy over this route. In fact, I think I can do this more efficiently, like so. wrap this, get rid of this, wrap it in lazy, and then we need to wrap these also inside of an import. And now if we save, let's go back to our application once we tidy up some of this spacing. And if we refresh, let's look inside of our network. We do see that our bundle size has reduced. We see it's down to 728 now. Now that number should only get smaller as we continue to code split dynamically imported route level components. So that's it, really. You've learned the majority of the different strategies that React provides for us when it comes to optimizing our performance. We can optimize at the callback level, we can optimize with hooks, we can optimize with React Lazy and React Suspense, as well as dynamic importing. But really, that covers the breadth of the strategies that React has available for us when it comes to performance optimization. I do want to mention once again that throughout this course, you have been learning a lot of the best practices and patterns of how to write optimal and performant code in the first place. Beyond that, we are also really focused on understanding the rendering and re-rendering cycles that exist inside of React as well. With all of that combined, you are now very equipped to begin writing beautiful and performant React applications. So that covers it for our performance section. Thank you, and I'll see you in the next video. Welcome back, everyone. In this video, I want to talk about Firebase security rules. Inside of your Firebase console, go into your Firestore database. Inside of this database, you'll notice that you have a rules tab. When you click this rules tab, your version of your rules may look different from my version. In fact, you will see inside of your version, most likely this list of original rules where every single document is readable and writable. So here, let's discuss how these rules work and the format. First off, looking at the left-hand side, you will notice that the history is being tracked of all of the changes between how the rules have been modified. My rule set is going to be different from your rule set because students may potentially accidentally download my actual configuration that allows their application to access my version of this Firebase database. So as a result, I have to make it very strict. I essentially only allow users to get users or read and write to them, but I do not allow them to update it unless that is their own student account. As for matching, I match every document that I allowed anyone to read, just in case, once again, you need to read from my database. But other than that, I do not allow any users to create or to write to this database. But let me go through these rules in a very simple way. Essentially, from the top level, rules are designed to be a series of match statements. So here, if you look inside, we're in rules version 2. I don't know if in the future Firebase will update to a newer version of the rules, but right now, the rules is version 2. The service is for Cloud Firestore, which is the database that we're running. This statement, match, matches a path to a series of documents. So of course, it starts with match databases and then the general database. So these angular brackets designate that any database inside of the database. And then the following documents are going to abide by the following rules. Now, to begin, we want only users to be able to access their own user profile, and we want users only to be able to modify their own profile. So we're going to match to that database, which is our users database. So we'll say /users and then /. And in here, you can isolate down to the actual user ID by saying user ID like so. Firebase knows that when you add this identifier ID, it will cast that variable so that it will know that if you're trying to access a specific user document by the ID, well, now you can only access it inside based on these rules. So we can say that we'll allow anybody to read, we'll allow anybody to get, and we'll allow people to create. So creating, reading, getting, no problem. But only you're allowed to write to it, as in you're allowed to update it, if the request, which is a special keyword, inside of these rules, meaning that with every request that gets sent to Firebase, there's a couple things on this special keyword that comes with the request. I'm going to say .auth, meaning that this user's authenticated, and only if they're authenticated. So I'm going to say that if this auth does not equal null, only if they're authenticated, and the request.auths.uid, meaning that their authentication identifier is equal to the user ID. Only if these are true can the user actually write to this user ID. Now, as far as the categories go, we can make a new line, and I can say match/categories, which is the name of our categories database in Firestore. And now if I do a wildcard, meaning that I access any individual category document. Remember, you cannot target collections. You can only target documents. You have to write this slash. You're not allowed to just put this. You have to do either with an ID or with just the base variable, essentially, through doing this wildcard. Here, I'm going to allow reading only, because I don't want anybody to be able to add categories, modify categories, or anything like that. I can allow myself to write by saying allow write if, once again, request.auth does not equal null. And I can say request.auth.uid equals, and then I can paste in here the UID for my specific user. If I can find my user that I want to be allowed to actually make write requests, I would just paste that in there. But I'm not going to put that here in case anybody sees it. So I can just say allow read. Now, one more thing I want to mention. If in the future I were to add additional properties or additional tables into my database, I may forget to update the rules here, and I want to match everything else that does get added. So to do that, I'm just going to say match slash and then document equals and then 2 wildcards. This is enough to tell Firebase, hey, I want to match every other document inside that has not already had rules defined for it above as we see. And then here, I'm just going to allow read for all of those ones. And this is my updated rules. I can publish these, and now my Firebase is more secure. I'm going to link for you additional documentation to these rules. You can actually get pretty hairy with them, but for our application, it's pretty simple. There's not that much to learn about it. But if you really wanted to get really verbose with it, you definitely can. You can even try and implement a cart feature where we store the cart inside of Firestore. And remember, only the user who owns that cart should be allowed to access it. If you wanted to access it, how would you do so? Again, you may have to look through the docs to figure out how to implement that feature, but it would be an interesting feature to try out. So that's it for Firebase rules. I'll see you in the next video.
Hey, it's Andre here. I want to talk about an important principle, which is this idea of not overcomplicating things. So far in the course, we learned a ton. And there are so many more things, so many libraries, so many tools that we can use. And it's very, very easy to start using perhaps the latest React features, the latest, coolest library. Keep adding all these tools and trying to make your code look impressive. But that comes at a cost. Remember, when you're working on a team, when you're working with others, when you're working on big projects, how many lines of code you write isn't indicative of how good of a developer you are. I argue that the less code you write, the better it is, because every line of code means you need to test that code. It could be buggy code. It's a code that somebody has to read to maintain it. So you want to make sure that when you write code, you're not doing things just to look impressive, just to be clever. What you want to do is to keep things simple. Do you think that React hooks is confusing? Good, then don't use them. Use class syntax. Because good code isn't about what's the latest and what's the trendiest. Good code is about writing really predictable, clean, understandable code. And senior developers understand this. The cleaner your code, the simpler it is, the better it's going to do in the long term. So remember, next time you want to implement GraphQL, React Router, React Hooks, Context API, Styled Components, just for your simple to-do app, that's when you need to stop and reconsider. Hey, don't overcomplicate. Keep things simple. Hey there, it's time for another lesson. And the lesson in this video is to be a late follower. What do I mean? React is a tool that's constantly evolving. No program, no software, no library is ever perfect. So the community is constantly improving it. Right now, React's version is 16.8. But by the time you watch this video, most likely it's going to be higher and higher because it's constantly improving. You have things like React hooks that were recently added. We're going to have suspense, concurrency mode in React. There's things like React Fire, React Fiber. A lot of planned updates that are coming. And sometimes it can be overwhelming to keep up with everything. And this is my advice to you. Usually what happens when something gets announced is that people get really, really excited and they start using it right away in their project. The problem is that sometimes developers don't get it right the first time. It takes some time to develop best practices. Sometimes maybe the API isn't good enough, so they decide to change some things. Because of this, when you're looking at React for your project, you want to make sure that you do things that aren't going to change. Ideally, your project can last a long time. If you're adding the latest features, what's going to happen is most likely a year down the road, somebody realizes that there's a better way of doing it. So take your time. If something's new, learn about it, get excited about it. But be cautious that just assuming that it's the best way to do something is not always the case. Usually, you want to give it a bit of time. Somewhere around a year until the community settles on best practices. If you were at the beginning when React got started, I remember people were doing things that, just doesn't exist anymore. People were building components in ways that actually doesn't exist anymore. So all those people had to update their code base because of these changes that were coming. I remember working at a company in Silicon Valley, and we implemented the latest version of React Router. And unfortunately, it was not well documented because it was so new. So we had to spend a really, really long time waiting for the API to settle before we had a working product because we chose to do something that, was at the very cutting edge. So be a late follower. You don't want to be the first one to try out something. Sometimes it's good to be behind the early adopters. This advice works not just with React, but in programming in general. And right here, I say trim the fat, but what I really mean is that breaking down things into small, simple units is a good way of programming. You have a giant component with a lot of JSX, good. Then most likely what you want to do is break that into smaller components. Sure, it might be more JavaScript files. You might say, that's going to get a little too messy, too many JavaScript files. Well, then I argue that perhaps you should organize your files in a better system. Because although, we might have more JavaScript files, we'll have more components. What we do by breaking things down is that we make things easier to test, easier to understand, and less likely to break, right? If things are just small units that just concern themselves with one specific thing, they're less likely to break. They're also easier for people to understand. They open up a file and you have 30 lines of code. That's easy to read than a giant component that you have to go line by line to figure out what's happening. So 99% of the time, if you think that component can be broken down into smaller components, go ahead and do it. Although it just may generate more files of code, in the end, as projects get larger and larger, the idea of having reusable components becomes more and more important. So, trim the fat, people. This is a big one. This one I hold dear to my heart. And it's the idea that things will never be perfect. No matter how hard you study, no matter how many videos you watch, how many books you read, how many projects you build, your code is never going to be perfect. A lot of people hold off on shipping a product or building something because they think they still need to improve something. They still need to learn, or they still need to add that feature, add a bug. But the problem is that this is a continuous cycle. It's never going to be perfect. Things are always evolving, and there's always going to be different ways that you can refactor code. Make things maybe more efficient, cleaner looking. The problem is when you have this mentality of, oh, I'm going to have to wait until it's absolutely perfect, is that you end up just bottling all this productivity inside you. But until you put out your work, until you do something in the real world to solve a problem, everything is internal. All that code that you write, if nobody sees it, if nobody uses it, it might as well just not be there. So keep that in mind. It's better to just start doing something, start putting something out there, start releasing that product, because no matter what you do, it won't be perfect. What you want to do is constantly improve. And the best way to improve is to get feedback on your code from other people, feedback on your product. So I guess what I'm saying is, stop watching these videos. Close your laptop. Well, don't close your laptop, we're programmers. But close this video, open up your code editor, and start writing your project. Good luck out there. Finally, let's finish off our talk with front-end performance optimizations with progressive web apps. So, what is a progressive web app? Well, a web app is a website that allows users to interact with the web page in many ways. However, whether it is a game, Twitter, or Facebook, it is inside of a browser window, such as Chrome, Safari, Firefox. A native app, on the other hand, is an app that is on a mobile phone, like an iPhone or a Samsung. That's what native means. It's meant to work on a native platform like a mobile phone. So, do you ever wish that web apps that live inside of browsers behave more like real apps on your phone? Well, progressive web apps are a new technology that's aiming to make that happen. Just like your apps on your phone, we want the user to have similar experience when visiting the web. But first, let's talk about the differences between the two. To create a web app, all you need to know is some HTML, CSS, and JavaScript, and you're good to go. To create a native app, that is a mobile phone app, you need to learn a native language, like Java for Android apps, or Objective-C and Swift for iOS apps. Unlike viewing on the browser, native apps have all the files they need on the user's mobile phone. For example, if you go into your phone and go through your apps, you can see how big some of those phone apps are by looking at their file size. And that's because unlike the server-client relationship that a web app has, where it has to go through, request HTML, and finally get the CSS and the JavaScript files, you can download native apps and have them on your phone, the files just living on your phone. The only thing you can really do with a web app is maybe bookmark a website. Additionally, native apps can send you push notifications. They can even work offline. And you're never going to get a blank screen. For example, if we go to GitHub and I have my Wi-Fi turned off, if I refresh the page, well, I get this little dinosaur icon saying there's no internet connection. You've never seen that on a native app, have you? Because native apps are built to work offline. Maybe not have full functionality offline, but still work and not get a blank screen. Finally, with mobile apps or native apps, you can find them to download in places like the App Store or the Google Play Store. You can't really do that with web apps. Oh, and I almost forgot. With native apps, they also have access to the phone hardware, like the camera, geolocation, push notifications. All right, I hope you get the point. Right now, our mobile apps and our web apps are not really the same thing. And mobile apps tend to work nicer than web apps on phones. And this is where progressive web apps come in. You can now make web apps behave like native apps. What do I mean? Well, with progressive web apps, you can make your browser not have that top URL bar so that the entire app covers the screen and looks like a mobile app. You can download them on your phone and have an app icon on your phone home screen. They can work offline. They can send push notifications on your phone. And they also work a lot faster, just like on phones, a lot more than regular web apps because they're designed with mobile in mind. And there are a few other features of progressive web apps, all in a goal to make them as similar as possible to native. So think of progressive web apps as web apps, but they behave more like native apps. Don't worry. It's a lot easier to implement than you think. Like existing web apps, they'll be hosted directly on their associated website. Developers can update them directly on their web server by deploying or updating their GitHub if it's hosted on GitHub pages, without submitting those updates to several different app stores. Because to update an app on the iOS App Store, you have to submit those changes and get those approved by Apple. With a progressive web app, you don't really need to do that. And the best part of all, that same app is going to run on all browser platforms. That is, if the phone is using Safari, it's going to work on Safari, it's going to work on Firefox, it's going to work on Chrome. And you don't have to worry about it being built for Android or iOS, or even Windows. All right, so what's the goal of all of this? Well, obviously, better user experience, faster websites. And we already know how important this is from our previous videos. Many people are really excited about progressive web apps, and although it's fairly new, it's catching on fast. And best of all, with new HTML5 APIs, we're starting to get more and more access to phone hardware that only native apps used to have. If you go to whatwecando.today website, it shows you what you can do in a web platform when you're building your app. And you see that we can do notifications, we can do audio and video capture, we can do geolocation. So we're starting to get more and more power with our web apps. Now, here's an interesting thing. Who do you think came up with the idea of progressive web apps? Give up? It was Google. Now, who do you think is the slowest in supporting this idea of progressive web apps? Give up? It's Apple. Because the goal is to make web feel like an app. And you can look at the companies and their interest and see why they would have this stance. Google, for example, has a big market share in the web. They're interested in their Chrome browser and their google.com search results to be used as often as possible. While Apple has their closed ecosystem of the App Store. And if you want to build an app, well, you have to build it the way that Apple wants it, using Objective-C or Swift, and using their developer platform Xcode, and submitting to their App Store to have an app. So Apple is interested in keeping their dominance of apps on their phones, while Google is interested in keeping their dominance on the web. And it's always good to think about these things when looking at technologies developed by these big companies. It's often usually out of self-interest. I know that sounds pessimistic, but it is true. Although it benefits us, it's good to understand the overarching goals. Facebook, for example, has something called React Native. And just like we learned React Native is a way to build apps that work just like native apps. So using React, you can now build iOS and Android apps, all with pretty much 90% of the code being shared between those two platforms. Anyway, let's get back on track. Now, there's a constant battle with this as Chrome has adopted this progressive web app stance, and Apple, that has the Safari browser, has been really lagging in adopting these technologies. But anyway, this is a constant battle. And as with everything that I've mentioned so far, we don't want to pick a technology just because it's hip and cool and it's the latest craze. We want to make sure that it adds value to our project. Now, progressive web apps are going to evolve over time. But the main takeaway is this: progressive web apps do enhance the experience of our users, even if it isn't everyone, like people with iOS. If it is easy to implement, then we should consider it though, because adding it to our project, even if it helps just a few people, it still is beneficial. And as time progresses, hopefully more and more adoption happens. And this is exactly why Create React App already comes preset with progressive web app capabilities. Yeah, you heard me right. They do it out of the box for you. Once again, Create React App helps out a ton here. With a little few tweaks that I'm going to show you in the upcoming exercises, we can have a progressive web app pretty fast. So I argue that because it is so easy, it's already set up in Create React App, we should implement progressive web apps abilities because it makes the user experience better and definitely improve performance. But how can we make our RoboFriends app into a progressive web app? I mean, remember that's what Bruno asked us to do? Luckily for us, Google has created something called Lighthouse. And this Lighthouse is a plugin, a Chrome plugin that we can just install. You can see it over here. I already have it installed, and run it on any website. And it'll tell us some performance metrics and also how close we are to that progressive web app. And I have here for us our RoboFriends app with Redux already set up. And I have a link to the website because, well, we need an actual URL. So if I click on this, I can go to Lighthouse plugin and say, generate report. And this is going to generate for us different reports. It's going to turn the app offline and then online again to see if it has any offline capabilities. It's going to check if it has any other features that a progressive web app will have. And we get a report back. And as you can see, it gives us a few extra things like SEO, best practices, accessibility, which we're going to talk about, and also performance. But the number that we're interested in is this progressive web app number. We see that although we haven't done anything, we have 82%. I mean, it's green. That's good, right? If we scroll down to the progressive web app, it even tells you what we can do to fix this. Now, how do we have 82% when we haven't done anything? Well, like I said before, Create React App sets everything for us so that it's easy to implement. And don't worry, we're going to go through this and get this to 100% in our exercise. But for now, that's enough talking for me. I'll see you in the next video. Bye-bye. Think of a progressive web app more like a running list of things you can do than a static list. It's going to evolve over time, but the idea is to make user experience, as we know, as close as possible to a native app. By the way, maybe you don't trust me. Maybe you think that this progressive web app is just pure hype and Andre is just teaching us something that won't exist in 2 years. Well, companies like Twitter have adopted progressive web apps, so much so that Twitter has moved all of their mobile web traffic to a React progressive web app. Alibaba.com, yeah, they use a progressive web app. Lyft and Uber uses a progressive web app. Lyft, for example, has a goal of making their progressive web app 100% parity, or have complete feature set that their mobile phone has, their mobile app has, to be the exact same as their web app. And there's tons of companies that are adopting progressive web apps because it is so beneficial. Let me show you a few examples to really emphasize and make you understand what this PWA is. One of the great examples that I like is this Pokedex.org website, a very, very simple website that shows you Pokemon information. Everybody loves that. Now, this is a progressive web app. Well, how so? If I go open up the developer tools, and you see over here, if I click on the icon that shows toggle device toolbar, and I scroll down here, it'll show me the mobile view of this app. Let me scroll down so we can see it fully. And we see over here that it looks pretty good on mobile. I can even turn it around. And we also have the menu that's working. But the cool part about this is if I turn off my Wi-Fi, which usually gives us that blank page with the dinosaur on Chrome saying we don't have an internet connection. Well, check this out. This still works. How cool is that? If I had this on my phone, even though I don't have an internet connection, I would be able to still check out all these Pokemons. All right, let's turn back the Wi-Fi and take a look at another website. And this is the Hacker News Progressive Web Apps. And you can think of it as a playground where people try and rebuild the Hacker News website using a progressive web app. And you can see here it gives us the Lighthouse score. It gives us some important metrics like how fast our web page loads. And you can even look at the code of people that have implemented this. Now let's click on the View app over here for one of the examples. And we see over here that we just have a simple Hacker News website. The cool part about this, and this is a thing that we'll talk about later on in the videos, is if I open this tab, now let's scroll this tab up now, and we go to Application, scroll all the way up to what we call the manifest, we see over here that there's a Add to Home Screen button. And this Add to Home Screen button appears for mobile users if I've visited the site multiple times. It's going to have a pop-up, and you might have seen this while browsing the web as well, that says, hey, do you want to add this to your home screen? You see over here, if I click that, I get this little notification. If I click on Add, I can add the application. We'll keep the name the same. And now on my desktop, look at that. I have Preact Hacker News app straight on this desktop, and it opens up right away. If I turned off the Wi-Fi and open this up again, we see that it still works. How cool is that? And you still see the URL bar because this is a browser. But if we were on a mobile phone, you actually wouldn't see this URL bar and it will feel completely like an app. Very, very cool. You see here that we don't completely have full features because you still need Wi-Fi for some parts. But that's okay, right? Because native apps work like that too. There you go. It's starting to load now. All right. So I think that's enough examples to prove to you that maybe we should consider doing this whole progressive web app thing. In the next few videos, I'm going to show you the 3 most important parts to build our own progressive web app. And we're going to talk about these 3 topics so that our RoboFriends app is going to be a progressive web app by the end of this section, and Bruno is going to love us for it. I'll see you in the next one. Bye-bye. Welcome back. In this video, we're going to talk about this first point, HTTPS, and why we need it for progressive web apps. Now, progressive web apps have a certain checklist you can check out on the progressive web app checklist. And I know, I said that there isn't a checklist. Think of progressive web apps as a running list, but that's because these are probably going to get constantly updated and changed. Now, this checklist, as you go through it, does look a little bit overwhelming. But we've been following good practices while building our apps, just like we did with the RoboFriends app. And you've actually done most of these things. So that's why instead of showing you this, we only really need to focus on 3 main things that a progressive web app needs to do. Now, beside these, there's a few features, but the adoption for them, such as push notifications, haven't been that smooth or are still in the works. So for now, we're going to focus on things that you can implement right now fully and be confident that they're going to work in your app. So, HTTPS. HTTPS, as you know, since we mentioned it a little bit in the SSH section, prevents bad actors from tampering with communications between our app and browser. So that if we're sending, let's say, a username and password to our server, we can encrypt it so that that message that includes our password travels to the server in an encrypted fashion, so that if Bob, the evil third-party hacker, is trying to intercept the messages and read them, even if he intercepts the message, he won't understand it because it's encrypted. And again, this is something that we talked about in my previous course. Now, Google is really pushing for this HTTPS encryption. And if we go back to our websites, we see that HTTPS, we have this little nice lock icon with secure. That's a good sign. Chrome has actually updated so that if you have any sort of forms on your website and they're not HTTPS, it'll show up here as not secure, pretty much shaming websites for not using HTTPS. So anytime you're sending data from the client to the server, you should be using HTTPS. Now, why do we need that though for progressive web apps? And that is because progressive web apps use some features that we're going to talk about in other videos that require HTTPS for security reasons. Although this is a requirement for progressive web app, in general, you should always serve your websites if there's any sort of communication with the server through HTTPS. And if we go to our Lighthouse report, you see that when we scroll to progressive web app and we check out the 9 past audits that we have uses HTTPS as one of the requirements. But how did that happen? How do we have HTTPS already? And luckily for us, we get this out of the box with GitHub Pages. You can see over here that this link that was generated is HTTPS. So anytime you put a website on GitHub Pages, we automatically get this encryption, which is fantastic. But not all websites can be hosted on GitHub Pages. You probably want to have your own server, your own domain name. Well, the easiest way to get HTTPS is probably through Let's Encrypt. Let's Encrypt is a free, and it says over here, it's a free, automated, and open certificate authority. And they're fantastic to use. And a certificate authority is just this authority that says, I'll give you a certificate to certify that, yes, you are indeed whoever you say you are, whatever your domain name is. And Let's Encrypt gives you free certificates that is really, really easy to set up. And they have great documentation for you to use. I highly recommend them. You also have something like Cloudflare. And Cloudflare is a CDN, or a content delivery network, which we're going to talk about in later sections. But for now, you can think of them as a server that you can put your files on. And just like GitHub Pages that hosts your files on their servers, Cloudflare hosts your site on their pages. And automatically, through them, you get HTTPS. And if you go to their pricing, they're actually very, very generous, and there's a free plan for personal blog posts and any simple websites that you have. Again, I highly recommend them, and they actually do improve your performance of the website as well. Again, something that we'll get into in the Performance Part 3 section. Going back to our website, this is something that we get out of the box. Our app is going to work with all the other features of Progressive Web App because it's on GitHub Pages, and we automatically get this HTTPS. Awesome. And we can double check over here with Preact Hacker News that, yep, indeed, they are using HTTPS as well. All right, that's it for now. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about the second point of making a progressive web app, and probably the cutest little icon that I'm going to have in this course, the app manifest. Now, for a progressive web app to behave like a native app, we need to mimic not just the function of a native app, but also some of the views that we get with it, or the shell. For example, on your phone, you can download an app and have an app icon. On Android devices, you have things such as splash screens. The idea is to make the web app as indistinguishable as possible to a real mobile app. And we can do that with the app manifest. Before we get into it, though, the one thing I do want to point is that a lot of people forget to include in their index.html file this line over here. And this comes out of the box with Create React App. You can see that I'm in the public index.html folder. And this line, which is the meta tag with viewport, optimizes the app for multiple devices. And this might seem super obvious, but a lot of people forget it. And this line helps with adjusting the screen size based on the device. So this is a must, and it will warn you if you're missing this line in the Lighthouse report. So now that we have the screen set up for mobile devices, let's talk about the app manifest file. And as you can see in our public folder, again, this is something that we get for free from Create React App. And this is it. This is the manifest.json file. It's a simple JSON file that gives the developers the ability to control how the app should appear to the user in areas where they would expect to see apps, such as the mobile device home screen. And just define how the app is going to launch and how it's going to look. So if you remember, in my example over here with this Hacker News app, we had the Add to Home Screen button in the Application tab. And you might have noticed that we actually clicked on this thing called manifest in the application. And that's the manifest.json file. The browser reads this and spits out this little piece of information for us. And if I scroll down, you see that I have icons here that get downloaded, just like I did for when I downloaded it onto my home screen. And this is the icon that you'll see when you download this app on your mobile phone. And it also gives us this nice little feature to add to home screen. So this is the app manifest file and what it does. Now, how do we generate these icons? We see over here that Create React App has generated a favicon in the public folder. But we're missing a few things, aren't we? We don't have all these other sized icons for mobile phones because we still need to generate them for our app. And you can see here that they have different sizes based on whichever device this gets downloaded on. Luckily for us, there's a great tool that does this very nicely and easily. It's called Real Favicon Generator. And this, all we need to do is provide an image, such as an image of a robot, by just clicking on Select Favicon Picture. And it'll take you through the steps to download these. And all we need to do is include them in our public folder, just like the favicon icon was, and reference them in the manifest.json file. And don't worry, this is exactly what we're going to do in our exercise to turn our RoboFriends app into a progressive web app. Another thing that this website does for us is previewing and customizing the splash screen for our manifest file. Now, what is a splash screen? In older versions of Chrome for Android, tapping on the home screen icon for an app would often take up to a couple hundred milliseconds. Before that screen gets loaded, a user would see a white screen, which makes the experience a little bit jarring, and it looks like the website is loading really slow. So Chrome 47 and above support this idea of a splash screen, where you can add a background color when you tap on the app, the progressive web app. Instead of loading the white screen, it's going to load something called a splash screen, where it'll have the background color, the name, and icon of the web app. And it will get that all from our manifest.json file. And this is all done simply to make your web app feel a lot closer to what you see with native apps. When you click on native apps, even if they're loading, they have some sort of a background and icon to show you that it is loading. Overall though, that's it. That's pretty simple, right? All we need is some icons and add them to manifest.json file. That's it for now. I'll see you in the next one. Bye-bye. All right, it's time to talk about the very last point, the service worker, to make our progressive web app. What is a service worker? Sounds like something useful, doesn't it? Service worker is a script that your browser runs in the background, separate from the web page web app. It is generally used for features that don't need a web page or user interaction. Remember the main thread that I kept talking about? How there's one worker that's trying to work with HTML, CSS, and JavaScript? Well, think of service worker as another worker that you now have in the browser, a background worker. And it acts as what we call a programmable proxy, allowing us to control what happens on a request by request basis. And it's the reason that we can make our apps, our progressive web apps, work offline. That sounds pretty interesting, right? Now, service workers have been recently added into browsers, including Safari. And besides offline experiences, it also helps with background syncs and push notifications. But we're only going to talk about how Service Worker allows for offline experiences because that's its main feature. And things such as background sync and push notifications are still fairly new and best practices are still forming around them. I'll leave resources for you to explore this further if you're interested in those topics. But for now, let's get back to the most important part. How do we use a service worker? Well, if we go back to our Create React app, you might remember that we created within our Create React app, well, we didn't really create it. It created it for us, this file called Register Service Worker. And if we go to index.js, we remember that in our main app that we render, we had our React DOM.render, but also we had this function, Register Service Worker, that I kind of brushed it off up until now. This Register Service Worker gets imported from, yep, you guessed it, our Register Service Worker file. And as you go through this file, it can look pretty overwhelming, but they have great comments to show you what it does. But let me show you the gist of it and what this entire file is doing. It's a lot simpler than you think. Let's open up a new tab here and open up our console. This is what the Register Service Worker is doing. That's a little too big. Let's see if that works. It checks for browser support of Service Worker. So it's saying, hey, do we actually have Service Worker in our navigator or our browser? And remember, each browser has its own developer teams, and each browser can decide to implement this new feature called Service Worker or not. There's actually a really good website called Is Service Worker Ready that I'll link to, where you can see which versions of the browsers have implemented service workers. If we go back, we do this check because we want to make sure that when we do navigator.serviceworker, we don't get an error saying, we don't know about service worker. What are you talking about? So we say, if there's a service worker, we want to use this service worker property of the navigator, that is the browser, and we want to do something called register. And we want to register it using this file, this serviceworker.js file. And registering is just the common way for you to create a service worker on your web page. Now, where is this service worker.js coming from? If we go back to our app, this service worker.js is getting created from this file in our build folder. When we run npm run build in Create React app, we see that we now have a service worker.js file. And it's minified, so it's really, really hard to read. But all it's doing is running the default registration of the service worker that you can pretty much grab anywhere online. And that's it. It's literally just one single line. You see that it's a promise that returns the registration, and we can just log out some properties on it, but there's a successful registration. And if it fails, well, it fails, and we can say, oops, service worker registration fails. With just this if statement, we check if the browser has service worker, and if it does, we just simply run the register function. Fairly simple. Now, registering the service worker is going to cause the browser to start the service worker install step in the background, again, with the other worker. And once a service worker is activated and registered, this success case, it's going to be in one of two states. It's either going to be terminated to save memory, or it's going to be running in the background to fetch messages and events that occurs in the network request. Now, what does that mean? Before I get to that, let's go back to our application. Let me make this smaller. Go to the Application tab. And you'll see here that we have below Manifest the Service Worker tab. And we see that Service Worker right now, there's nothing here. But if I go to our demo app that is a progressive web app, and I click on Service Workers, we see that, oh, there's something here. It looks like there's a service worker that has been registered from serviceworker.js. It shows us when it was registered and the status. And right now it's stopped because, well, we're not doing anything with this page. We can unregister the service worker if we want. But it looks like on this web page, we have this service worker running. Let me show you a diagram to illustrate to you what this all means and why we care. You see, without a service worker, our browser is going to send a request to the network. This little icon, you can think of it as the internet network. We send a request, we find the server, and the server responds back with some files. Let's say a JavaScript file. But now that we have a service worker registered, we tell the browser, hey, before you go ahead and do this, talk to the service worker first. Maybe he knows something. You see, in a progressive web app, the service worker acts as what we call a network proxy. It intercepts any requests made first to the network, like I said, step 1 over here, and checks to see if you really need to communicate with the network, because maybe he already has those files. When a user opens a new screen of a progressive web app, the request for that page first goes to the service worker, not the network. The service worker then tries to access something called the Cache API. And this is something that the browsers give you. Again, most browsers have this because they included this feature with Service Worker. And this Cache API is kind of like a box where the browser stores files, such as JavaScript files, CSS files, any static files. It could be images. It could be anything you want. The worker tries to access, check the box and see, is whatever I'm requesting inside of this box? If the content is available, then we'll get the new page through here and the service worker is going to return the page. Regardless of the network activity, we're never requesting to the network. But if the service worker comes back and says, Mr. Browser, I don't have the file that you requested. You're going to have to talk to the network. Then we go back to talking to the network the old way that we did things and getting those files. Now, what is this cache storage API? Again, if we go back to our example and scroll down to cache, we have something called cache storage. And this cache storage is exactly what the service worker checks. If I click over here, we see that, oh yeah, we have a cache of a few JavaScript files and also some HTML. If I go to the other one, I see some icons that are also, and some lists that are also being cached. Very cool. So we cache the website or the shell of the website. Remember, whatever we want to work offline in this cache storage API via the service worker. So that on repeat visits, even though the very first time the user browses and goes to a website, it'll have to go to the network because this cache API will be empty. Once the network returns with those files, we can cache those files, and on repeat visits, the app shell can be loaded instantly. All right, stop talking, Andre. Show me how we can actually do this thing. Show me some code. Well, you're in luck. In the next few videos, we're going to go through these steps and finally turn our app into a progressive web app. Before I do that, again, I just want to show you how things work underneath the hood. If we go back to our Create React app, I wanted to show you how this would work before Create React App implemented service workers. Because right now it's kind of being done behind the scenes for you, which is really, really nice. But what if you had to implement it on your own? It's actually quite easy, and you can look at this page that I'm going to link to show you what you would have done. If you go over here, we see that all we needed to do was download something called Service Worker Precache. And in our build step, where we say React scripts build, we would just run this command, the Service Worker Precache with config of this file. Kind of similar to how Webpack config worked. So we give it this configuration file. In our index.html, we do the classic if service worker exists in the browser, we're going to register the service worker. We have our manifest file that we add. And then finally, with this package that we installed, SW Precache, well, here all we're doing is setting up the config, telling it that we want to use the build folder, and I want you to put in the cache any file that's an HTML file, and any JSON files or manifest.json file, and anything in the static folder. And we're going to use the serviceworker.js file path. That's it. And if you remember, in the static folder for Create React App, we have our CSS, JavaScript, and some media files. How simple is that? Very, very cool. Again, remember, we're just using the tools that browsers provide for us to make our websites faster. That's it for now. I'll see you in the next one. Bye-bye. Now that we understand progressive web apps, I just wanted to add a few closing thoughts. Progressive web apps have a great goal in mind. Make websites faster and better for the user. However, as with all new technology, it still has some kinks to work out. As you can imagine, it isn't really in the best interest of Apple, as we mentioned before. That's why Safari support is really slow right now for progressive web apps. It'll improve over time, but you have to be careful between the browsers what works and what doesn't when building a progressive web apps. Things such as push notifications can be achieved on some browsers and not others. And Push API and the Notification API that uses push notifications requires integration with the backend. That adds an extra layer of complexity. And does everybody love push notifications and getting bugged from an app? I know that when I'm visiting a website, getting notifications to add it to my home screen is really, really annoying. Did you actually ever download an add to home screen notification? Companies like Twitter and Tinder use progressive web apps, and companies like Lyft are really trying to make their progressive web apps as similar as possible to their native apps, which is always a good sign. With these sort of technologies, be careful not to just get caught up in the hype. Every situation is different, and depending on your project goals, you may or may not benefit from progressive web apps. As always, decide if the effort is worth the benefit. Luckily, for most projects, progressive web apps does help, because even if it's not all the features that are being used, the browsers that do support it will give a better experience for the user.
Welcome back, everyone. In this video, we are going to talk about how to migrate our application from a non-progressive web app to a progressive web app, learning all of the things that Andre has mentioned in those progressive web app lessons that we just saw. To begin with, we built our application using Create React App. The interesting thing is that there is actually a way to initialize your project so that it comes with the correct progressive web app files in place and all the different bundles that we need, as well as the libraries. We didn't do that so that we can see what the migration looks like. And the other thing too is that Create React App has recently, in the past year, made it so that the progressive web application part is opt-in, whereas before, the moment you used Create React App to build any application, it came with the required progressive web app actual things. But the thing is that it's not that popular anymore. There was a while where progressive web apps were really a big trendy thing, but now the actual usage of it has not proven itself that useful. But again, it's still an interesting part of the web experience and the web technologies available. So we'll learn about how this migration works. The easiest way to do this is actually to generate a template of a new Create React application, take the relevant files, copy them over into our application, because they're pretty much the most efficient Create React app setup for a progressive web application. So to do that, what I'm going to do is I'm going to go to another folder and I'm going to run Create React app again. And this time I'm going to call it something like PWA test, just as an example, because I really just want that progressive web app template. So that right there is the name. I named it PWA-test. And then I'm going to say --template CRA template -PWA. Now you can do this and this will generate the JavaScript version, or you can say -TypeScript, which loads another template, which builds the TypeScript version. Now let's just wait for this to finish actually running. So there we go. We finished building our project. Let's just cd into it, open it up, and take a look at what we got. So generally speaking, inside of this file, there are a couple things that we want to copy over. One is pretty much just this React app environment file. All it does is it just makes references to React scripts. We have this report web vitals file. This one you don't necessarily have to have, but at the same time, we can move it over. Service worker.js. Again, the service worker is very critical to actually getting the progressive web app to work, as you remember from Andre mentioning it. And then we have this service worker registration file that will actually call the underlying service worker. So what we can do is we can really just copy these 4 files and just paste them directly into our own project. So we already have a report web vitals.js file. So what we can do is we can really still just paste this in. I believe we do it in the source folder right here. And there we go. So of course, web vitals.js versus report web vitals TS. There's not much difference except the TS one is TypeScript. So we could just get rid of the JS one, just because we are already in TypeScript world anyways. And now that is all we really need in order to get the service worker registered inside of our code. The other thing we need though is actually the libraries that all come with the actual new progressive web app based application. This is all of these workbox libraries. And what these do is they make it easier for progressive web apps to actually function inside of the Create React app context. So let's just copy these over. Let's go into our package.json and let's just add them at the very bottom here, like so. We're going to save this. And what we want to do is we want to go back to our actual application. I want to make sure that we yarn install all of these new workbox packages that we have just added. So here we are just going to load up everything, let everything install. A lot of waiting. And there we go. So now that we have this, what we can do is we can come back. And now there is one more thing we need to update. So inside of our public folder, we are using these logos that came by default with Create React App. But instead, we want to use the ones that come with our project. They should be our logos. Similarly, we want to update our favicon so that it's our own logo. And we also want to update the manifest.json to represent the correct logos. So what I want you to do is I want you to go into your resources folder. And I want you to find these files that I have already made for you, these 3 logo files. So what you can do is you can first delete the favicon icon because the naming of these ones are the same. And then you want to copy these over into your public folder, just like so. And then you can delete these existing logos that came with it. And similarly, inside of manifest.json now, we just need to update this so that it actually says and references our new icons. So first, I'm going to name this Crwn-Clothing for the short name. And then for the actual name, I'm going to say Crwn-Clothing by Yihua. The favicon here, this is fine. We just replaced the old favicon with the new favicon. But now this logo is not the correct name. I'm going to call this Crown 192 times 192, which is what I named it here. And then similarly, I want to do the same thing for this 512 one. So Crown 512 by 512. The other thing I want to make sure to add for one of these icons is a purpose. And I want to do this for both of these icons. And I'm going to say any maskable. I need this in order for Progressive Web App to actually know, hey, when I generate the icon for you that you use to open the actual app, I want any of these icons to be maskable, which just means that it's scalable. Again, Andre mentioned about maskable icons. That's all this is for. So now that we have all of our files set up, the last thing that we actually need to do is we need to run the service worker inside of our code. Rather, we need to register it. So I want you to go into index.js. And what I want you to do is I want you to import in the service worker registration code. So you're going to say import star as service worker registration from our service worker registration file that we copied over. And then we are going to run this after our app renders. We're just going to say service worker registration.register. And that should be everything we need. We're running our service worker. We have all of our files. We have our manifest. We're pretty much good to go. So now what we do is we go back into our terminal and we're going to run yarn build. And what this will do is this will create a optimized build inside of a build folder in our project. So let's just wait for that and we'll run that once this is done. So now that we have our final build folder, what we need to do is follow these two instructions in order to actually serve this inside of a package-based web server. So first, we are going to run yarn global add serve in order to globally install this serve package. And then to run it, we'll say serve-s and then the name of the folder. Now this one is automatically built into our build folder, so we will say build. And what this will do is it will take our built files and then serve them through localhost 3000. So let's go back to our browser. And what I want to do as well is I just want to make sure that I'm also in incognito. Incognito makes sure that nothing is cached. So just in case any of our files are having any type of caching issues, we can ignore those things. So now here, what we have open is our developer console. And what I want to do is I want to make sure that we have our progressive web app checked. So here inside of this Lighthouse tab of our developer console, we can now hit generate report. And this will tell us whether or not we have satisfied all of the conditions so that our application is appropriately a progressive web app. So let's wait for this to run. So there we go. We see that we passed all of our checks for a PWA and we have a progressive web app. So generally speaking, it's very simple. Even if you have a React application that you created with CRA that doesn't have progressive web app template, you can always just, again, copy over those files, make sure you have the maskable icons and everything, set up your manifest, and you're good to go. So that's it. We have our application migrated to a progressive web app. The next thing to do is to make sure that all of our styling for mobile is appropriate. So let's do that in the next section. Welcome back, everyone. In this video, we are going to cover moving and migrating our code base into one that also contains mobile styling. In order for us to capture mobile styling, we're going to learn a couple little tricks in CSS that are relevant for us. And we're also going to learn a little bit more about style components and one of their really useful components for us, which is known as the global style component. Now, right now, if you remember, we have access to a index.sas file. This index.sas file, we covered actually really early on, and we import it inside our index.js. And it contains some global styles that we want to apply on our body, anchor tags, everything else to make them box sizing, border box. Some of it came by default. Some of it I asked you to add in. But here, what we want to do is we want to actually be able to leverage this instead of using a SAS file, but to use the patterns that we've already used with style components. In order to do this, what we're going to want to do is create a new global styles component. And here I'm going to keep it inside the root source folder, which is where we've kept also our index.js because it's relevant globally, or at least at the very root level. So here I'm just going to make a new global.styles.js file. You can also make this a .ts file if you want, but for my intents and purposes, this is really something quite simple that doesn't really need Typescript. So what I'm going to do is I'm going to first import in this method called create global style that comes from style components. In order for me to leverage it, I'm going to create a component called global style. And this is pretty much just a style component. And what you do is you call create global style, and you, of course, pass it a backtick or a string in this particular case with string interpolation so that we can render JavaScript if we wanted to. But for me, I don't really need it. All I'm going to do is take what was inside the index.sas file and just paste it here inside of this global style file. So let's adjust our actual tabulation here. Let's save this. And now what we can do is we can take this global style component that we've just created. And what we want to do is we want to go into either our app.js or our index.js and add the component as you would wrapping the entire project. In my particular case, we know that the app is pretty much where the main part of all this code is going to be applied anyways. And what you do is you just import that component in. So here, let's import in the global style component from going up to our source file. Actually, we might already be in our source file. Yes, we are. So we're going to take this component. Actually, I believe this is also not the default export. Yes, exactly. That's what it is. And now I'm just going to paste this in here. I want to save this. And then I want to now delete the index.sas file. And I also want to remove the actual import because there's no file reference there anymore. So here, let's just go back. Let's make sure that we are running our code. So I'm just going to say yarn start to make sure that we're running everything and we can actually test that all of our styles are actually still being applied. And of course, now localhost is refreshing. Let's go in here and open up our actual elements code. Now here, let's just make sure to inspect one of our components. And let's look inside of the computer code. We see down here that we have that body styling that we added inside of our global style. So we know it's loading properly. We know we've properly migrated from an index.sas file into that global style component. Now, how is this working? Well, remember, this global style component is just a component. Anywhere that it actually renders in is also going to render in the styling that you have inside of that component. So here, the moment that our app.js loads, it's going to load global style, which in turn is going to apply those CSS rules into our actual CSS. And for us, because we're targeting body and anchor tags and all those things, all of this styling is going to apply. And that's it. That's all we need for the global styling. Now, the next thing we want to do here is on this page, we also want to style these different items. So here, what did we call these? Well, we called these directory items. So what I want to do is I want to first click this little button in Chrome here that makes it so that we are now in a mobile view. And you can adjust this if you wanted a tighter mobile view or a wider mobile view. But the whole idea here is pretty much just that we are now simulating a mobile viewport. For this component, what we want to do is we want to go into the actual component itself so we can modify some of this styling. So here inside of the home component, it is our directory. And in our directory, we have our directory items. So for our directory items, we want to modify the styling so that it has some of this mobile styling. And the way you do this is you go into the actual style code that you want to modify. So let's go into our directory item styles. Here, what I want to do is I want to modify this directory item container so that it has some of the actual mobile styling that I want for this. So here's what I'm going to do. I am going to, at the very bottom here, add in what's known as a media query. So a media query looks like this. You say @media, and this defines what we want to target. So we want to target our screen, meaning that, hey, I want you to apply some CSS rules whenever the screen size does some particular constraint. And in our particular case, we want it. So we want to say, hey, whenever the screen and whenever this max width is 800 pixels or below. So as long as the maximum width of the screen is 800 pixels or below, I want you to apply these CSS rules. And what I want to apply is I want to make it so that this directory item container has a height of 200 pixels. So now if I save this and I come back, and if I refresh, well, we actually just saw it work. We saw it flicker. And what we saw is that our different directory items now have a height of 200 pixels right here. Right here, we see our media screen max width 800 pixels, height 200 pixels. That's exactly what we're looking for. We now have this styling applied. So generally speaking, you might be thinking, well, Yihui, what about these breakpoints is the ones that we should use? Honestly, in different companies, there are different screen sizes that they choose to target specifically because there's so many different mobile screen sizes. But generally speaking, a safe bet is 800 pixels or below is going to be mobile. So that is what we're going to use ourselves. Of course, you can easily change these if you find your own different widths that you want to support and apply specific styling for. You can do that. But really, this is as simple as you really need in order to get started with mobile styling. So with this, we can change any of our styling so that we can now have some of our mobile styling. So that's what I want you to do. I want you to look at your application and I want you to reduce it down to that mobile viewport. Look at some of the things that you think might be you want to change the styling on and just try it yourself. Write some of these media queries, modify some of the CSS. This is a good chance to get your hands dirty with some of this code. And in the next video, we'll cover a couple together. I'll see you in the next video. Welcome back, everyone. I hope that you got a chance to play around with the media queries and style your mobile styling for the application. If not, that's perfectly fine. We'll do some together. So first, what I want to modify is I want my navigation bar to look a little better. So what I'll do is I will go into this navigation styles component. And what I'm going to do is first, inside of the navigation container, I'm going to add @media, screen, and max width 800 pixels. And the styling I want to apply is first, I'm going to reduce the height a little bit. I'm also going to add and modify the padding here. I'm going to say I want 10 pixels on the top and the bottom, and I want 20 pixels on the left and right side. And I also want a margin bottom of 20 pixels. So I'm going to save that. Here inside of the logo container, I am again going to just copy over this media query so that I don't have to type it again every time. And inside, I'm going to say, first, I want the width of this to be 50 pixels. I'm going to reduce the size of the logo. And also, I'm going to reduce it so that there's no padding. And then lastly, what I'm going to do is inside of this navlinks container, I'm going to increase the width because now that we've shrunk the logo container, I want the actual links to take up a little bit more space. So again, I'm going to paste in that media query, and I'm just going to say that I want the width to be 80%. And now if I save this, I come back here, what I see is that this looks a lot better for mobile. So the next thing that we want to modify is inside of our shop component. As you can clearly see, these different components are just really not working out. This looks really tight. We have no idea what we're looking at. So let's improve some of these components. Now these, of course, are product cards. So let's go into our product card styles and let's make some modifications. The first thing that I want to do is I'm going to want to target the product card container, and I'm going to apply some styling down here at the very bottom. Personally, I like to keep all of my mobile styling as low down the chain as I can. So again, it's the same media query that we were using up until this point. And first what I'm going to do is I'm going to set it so that the width takes up 40 of the view width. VW stands for view width. So whatever the actual viewport width is, I want 40 of that. So 40%, really. You can think of it like that. Now inside, interestingly, we can also target any of its children because remember, it's just CSS or Sass in our particular point. So I can easily also write the same kind of selection criteria that I want. So I want to say for the button, I want you to make this display block. I want the opacity to be 0.9. The reason I want this is because there's no more hover action anymore. Remember, with mobile, you don't really get the hover as you would with mouses. So we're going to modify some of our hover information, and we'll cover that a little bit once we finish some of this. I want to remove the min width because now that's no longer important. And I want to modify the padding so it's 0 and 10 pixels. So 0 top bottom, 10 pixels left and right. As for the hover, I'm going to say ampersand hover. And here I'm going to target our .image. And inside, first I want to say, hey, opacity, I want this to be unset. Actually, instead of .image, this should be image. And as for the actual button, I also want the opacity to be unset. So now if I save this and I come back here, what do we see the update to be? Let's refresh. Oh, there we go. The refresh is always a little bit off. So every time I'm showing this, sometimes I have to wait or sometimes I don't. But there we go. We see that this looks much closer to what we want it to be. But the problem, of course, is that now we are exceeding the actual size that we want this component to show. We don't want to have to scroll through. We just want to be able to display everything on one viewport. So in order for us to do this, we need to now modify where our product cards live. So let's think about what this is. This is most likely inside of our category preview styles. So here, what we want to do is we want to think about what we need to modify in order to make this work. First off, inside of the category preview container, what I'm going to do is I'm going to first say, okay, I want, again, this media. And inside, I want to first align these items in the center. Because again, we're inside of our flex box. So instead of doing just letting the flex run by itself, I'm going to align everything in the center. So now what we also want to do is we also want to now modify the preview. And this is the div that contains all of our actual product cards. And as you remember, we had display grid and we were just operating over so that there were 4 columns. But now instead, we don't have 4 columns. If each product card takes up 40 view width, meaning 40%, with 2 cards, you're already taking up 80%. Add in these gaps, you've pretty much got your full width maximum showing 2 product cards. And here, what I'm going to do is I'm going to make this modification. So again, I'm going to add my media query. And first, I'm going to say, okay, this is display grid. Now, this actually is redundant because there is already display grid present, so I don't even need this. Instead, I'm now going to say, okay, let's modify the grid template columns so that now it is 2 columns, 1 FR, 1 FR. And now I want to also shrink the gap. So I'm going to say the grid column gap is 15 pixels. But now that we are also doing potentially 2 different rows here, because again, there are 4 product cards. And if there are 4 product cards and there's 2 per row, then we also now need a grid row gap. And this one I'm going to set to 25 pixels. So now if I save this, I come back, I just give it a second to refresh. There we go. We now see that we have a much more viewable product card for our mobile experience. If I get rid of it and I close this window, you'll see it snaps back to what we had before. So the reason when I open this and you notice that it sweeps here is because the actual width in the corner is below our media query of 800. But the moment that I exceed the 800, you'll notice it snaps back. So that's how media queries work. Really handy. That's how mobile styling works. So there, now we have these product cards. If you wanted to add some more, you can also add some more, but this generally pretty much covers all of the different styling that I personally wanted to apply. Now, again, you can go through your application, make additional media queries. You can have multiple media queries for different sizes if you notice anything that's 400 pixels or below. Maybe you only want to show one card. You can easily do that very simply by just adding another media query like so. And you can say, okay, well, if I'm below 400 pixels, I only want 1 column. Now, again, you don't really need column gaps here. You just have your grid row gap. And what you also would want to do is inside the product card, such that if you are also below this, you most likely also want probably all of this styling. Again, you can extrapolate this out into a CSS block as we've worked with before. But instead, now you want the width, instead of being 40 view width, you can have this be 80 view width. Now, interestingly, remember, this media query actually, you don't even need to extract out this code into a CSS block and duplicate this. This screen width being less than 400 is true when it's less than 400. But when it's less than 400, it's also less than 800. So in fact, you'll notice that our button styling that we have in here will also validly apply when it's less than 400. So here we'll save, and let's just take a quick look at this. What I want to do, I want to shrink this back to mobile, and I'm going to make it so that the width is just under 400. And there you see our button styling is still present. But you'll notice now that everything is in 1 column as we set it. The moment I hit 400 and above, we switch over to this 2 column view. And that's pretty much it. You can now utilize media queries inside of your CSS and add any additional mobile styling that you particularly want. But this is all I want to do, and that's all I wanted to show you. So now that we've finished this, let's move on to our next lesson.
Testing is an important concept in programming. Although we start off writing a simple script.js file with a few lines of code, when we start getting into the real world, you start getting thousands and millions of lines of code, hundreds of JavaScript files. Files worked on by many people from different divisions in a company, and most likely all of them starting at different time at the company, all the code changes happening over time at different times as people work on the project. As the complexity of the code and the size of the code increases, it becomes harder and harder for someone to fix a bug that may arise. If you come into a project that has been around for years, you may modify something that may modify another part of the app that you didn't think of. And you start creating all these bugs with new features that you introduce into the app. the longer that code stays in a project, the more likely it is to be touched by different developers. So you see the problem here? For companies, this is a huge problem because you're most likely always growing your product and adding more and more lines of code. That means that they're just going to keep making this giant monster that becomes harder and harder to tame. And bugs cost companies a lot of money. Luckily for us, we have something called testing, which can help us solve this problem. As the name suggests, testing is a method in software development where individual units of source code, assets, or programs are tested to see whether they work properly. Although it may not be a big part of a coding interview when you first get started, it is a big part of any major software company that you work for. For example, in my case, when I first started out as a developer, I didn't know that much about testing, and I got hired without knowing much about testing. But the importance of testing grew more and more as I progressed in my career. And it's one of those things that we often overlook, and a lot of junior developers overlook. But if you want to become a senior developer, and if you want to have a long-lasting career, you really need to master this skill. Remember, every serious company is going to have tests, and they will want you to write tests for your code. So, how can we do this? Well, a test is simply another file in your project. This file never runs in production or on a product website. Instead, it runs in development. It's a file that you run to make sure before you release to production that what you just have written works as intended. Now, the best way to show you how it works is to demonstrate a test for you. So let's go to our RoboFriends app. I have the RoboFriends app here, but I've included a few tests just to demonstrate for you how it works. And by the end of this section, you're going to be able to write these as well. And we're going to write them together. But if I run npm run test, again, a command that comes with create React app, let's see what happens. I get a few things saying that no test found related file changes since last commit because I've already run the test. But if I press A, did you catch that? We have 6 test suites, 16 tests, and 5 snapshots that passed. All right, what does this all mean? And why do all these components have the .test.js file in here? I see a lot of green, which is probably good, but what does this all mean? And don't worry, from here, we're going to unpack it and see how everything works. We're going to learn about what tools we need, what tools we're going to use, and how we can become testing ninjas. By the way, you may hear the term TDD, or test-driven development. That is the idea of writing tests even before you actually write your application code, so that you start writing code based on the tests that you provide. And some people really love this way of working, and you can read up on it and decide for yourself if this is something you would want to try out. Now, to get back to the point. We are humans, and as humans, we make mistakes. It's unavoidable. As an application grows, it is impossible to think of all cases in your code and have all the if statements that take care of all use cases, especially not from the very beginning. Although adding tests will definitely decrease our development speed, since now we're writing more code just for tests, in the long run, if your project is of a certain size, it's always better to write tests because you avoid bugs in the long term. All right. In this section, we're going to learn all about it. As always, we're going to go through some core concepts and build our foundation, and then we're going to get to coding some of our own tests. Let's get started. Welcome back. Now, tests in general can be grouped into three main categories. Now, everybody has their own definition, and sometimes somebody's definition might overlap with the other category, but just as a mental framework, think of tests as having three main distinct types. The first are unit tests, and these are the most common, the easiest to implement, and the ones that are really important to have in your application. Unit tests, as the name suggests, tests individual functions or classes. So if I had a sum function, I'm going to just test that one function to make sure that it does what it says it does. Maybe if it accepts parameter A and B, I want to make sure that A and B get added with that function. They are the cheapest to implement, the easiest to implement, and 90% of your time, you're going to be working on writing unit tests. They're very, very useful. The second one is something called integration tests. This is testing how different pieces of code work together. So it can be testing of whether the database works with the Express app that's requesting some data from the database. Or it could be how a function works with another function and how this connection between them works and testing that. Finally, we have automation tests or UI tests. This usually involves testing real-life scenarios on the browser by controlling the browser and making sure that the expected behavior on the web is correct. Now, you can have humans doing this where they go through and click through everything on your website and make sure everything works. Or you can programmatically have robots or code that you write that runs through these tests for you. As we go down into this order, they become more and more expensive to implement. What does that mean? Well, automation tests, just by hearing about what they do, are a lot more difficult to implement than unit tests, right? So all these tests have their use cases, but have their pros and cons as well. And we're going to talk about each one of these. But for now, let's leave it at that. And in the next video, we're going to talk about some of the tools that you're going to encounter as you start to write tests. I'll see you in the next one. Bye-bye. Welcome back. In this video, let's talk about all the tools we can use to actually run our tests. Remember, our tests are just JavaScript. So we could just write simple JavaScript files with maybe if statements that says, if the sum function adds these two numbers together, then return success, otherwise return test failed. So we could do that, but that's tedious, and as developers, we want to use existing tools to make our experience or our speed of development faster. So this is going to get overwhelming, but let's look at testing tools. I tried to organize for you a way to think about tests and the testing environment in the web development land. So I'm going to explain this, and if this is a little complicated at first, don't worry. We're going to come back to this and go over this at the end of the section. It's all going to make sense. So the very first thing we need in a testing tool is something called a testing library. Pretty self-explanatory. This is the scaffolding, giving us the ability to use some function calls and some new methods for us to actually write our tests. Again, think of this as scaffolding or building the structure around our tests. Probably the top three libraries for that is Jasmine, there's Jest, and then there's something called Mocha. And like I said, these are just npm install libraries, so they're available on npm, and you can add them to build your scaffolding. The next thing that you need right over here is something called an assertion library. And in here we have, again, Jasmine that comes with its own assertion library. We have Jest, once again, that comes with its own assertion library. And then Chai here that usually gets paired with Mocha in order to have an assertion library. An assertion library provides functions that are assertion functions. I know that's confusing. It's essentially a tool to allow you to test that the variables contain the expected value. Now, that still sounds confusing, so let me show you. We're on the Chai assertion library here, and you can see over here that they use something called BDD, or Behavioral Driven Development. And by installing this library, we can use all these words, and they just look like basic English. What an assertion library does is says, expect that this object that just contains A equals 1, and then it chains all these words together to test our assumption. So let's say, expect that this object to not have property B. It reads like English, right? It simply tests condition 1 against condition 2. So this is going to return false because you're right, this object won't have property B. And they have a lot of things that we can add. We see that another one is expect this object to have all keys A and B. It kind of reads like English. And this makes our test really easy to read and understand. The next thing we need for our test is something called a test runner. And a test runner is something that allows us to run our tests. Remember, if we go back to our app, we had to do npm run test. And this runs our test. Let's press A to run all the tests. And something is magically running all these tests. That's what a test runner does. Going back to our slide again, we now see that Jasmine and Jest include a test runner in their library. And then Mocha also has its own test runner. And then I've added another one over here, which is called karma.js. And this allows you to run tests in the browser. What does that mean? Well, a test runner can run tests in different environments. Let's have a look. You see, usually our JavaScript works with the DOM to make our web app what it is. But when we're running tests, and this is what Karma does, allows you to run your tests on the browser. But why wouldn't we just always run our tests on the browser? Well, that is because it takes a lot of time. We have to run every single test through the browser using the browser APIs. Ideally, when we run tests, it's super, super quick because most tests are set up so that if a developer hits save on their terminal, it's going to run the tests. If every time they needed to start up the browser and run through everything, well, that would be really, really slow. So other options exist, such as Puppeteer by Google, which is what we call a headless browser. It's a node library which provides a high-level API to control the headless version of their browser. So think of it as a stripped-down browser that makes your tests a little bit faster. But it can also be configured to do things such as generate screenshots, PDFs of pages. It can automate form submissions. You can do UI testing with it. You can monitor keyboard input. You can do a lot of cool things with it. And then finally, we have something called JS DOM. And JS DOM, as the name suggests, is an in JavaScript implementation of the DOM. So it's not the real DOM, but a fake JavaScript version of it. And remember, the DOM is that tree-like structure that shows the nodes on our webpage. And that's what makes up our UI. So JS DOM implements this in JavaScript, so we can have a DOM-like API to work without actually needing the browser. If we go back to our tests. And let's run this again. I'm going to run npm run test. You'll see over here that React scripts test --env. It went by quickly, but you saw that we are using JS DOM there, so that our tests run really, really quick. All right. So that's a test runner. Next, we have something called mock, spies, and stubs. And in here, again, Jasmine and Jess come with their own version. And then if you're using something like Mocha, just like you had to add an assertion library, you'll have to add something called signon.js. There are obviously other libraries, but this is the most popular. Now, what's all this mock, spies, and stub business? Well, spies provide for us information about functions. How many times they were called, in what cases, and by whom. Stubbing replaces selected functions with a function to ensure that the expected behavior happens. And then mocks is kind of like faking a function or a behavior to test different parts of a process. So this might be really, really good for integration tests. Now, I know that can get a little bit confusing, so let's take a look at sign-on. Sign-on over here, if you go to their documentation, let's click on stubs. If we scroll down, we see that, what is a stub doing? We're simply using the library signon.stub, which is a function. Now we can use it in a way where this function can be called with arguments 42 and make it return 1. So that when we run callback 42, it returns 1. And when we do callback dot with args, it throws an error. Again, this is something that we'll go over later in the videos. But you see here that stub is we can fake functions and make them do what they expect. For example, sign-on can be used to fake a server during our tests. We don't necessarily want to send requests to the server every time we're running tests, but ideally, if a function is using a server, we can fake it with a stub so that the function still runs and we can just test that one piece of code. Like I said, this is really hard to explain without a little bit of a demo, but don't worry, we're going to get there. And then the final piece of the puzzle, we've talked about scaffolding, about assertion libraries. We talked about test runners. We talked about these stubs, mocks, and spies. Finally, we have something called code coverage. And code coverage is provided by libraries like Istanbul. Just has code coverage already included, but has actually Istanbul running underneath the hood. And let me show you what a code coverage might look like. Luckily for us, we can just do npm test -- coverage. And don't worry, we'll talk about how we can do this in our apps. But if I run this, you see the JS DOM here. I get an outputted file of the coverage. And you see over here that I have my RoboFriends app. And I have some greens, some reds, some yellows. And this is a test coverage that shows me what percentage of the statements, the branches, the functions are covered with tests. You see here that I've written some tests for the constants.js file, some actions.js file, and also for some of our components, some of our card list components, and that we have 100% coverage for those. But then we also have things like the header.js file that is missing some tests, and it even shows us which lines we're missing tests in. And that is Istanbul underneath the hood, giving us a report of where we're missing tests. Now, although these are a lot of libraries, they all have the same goal in mind, and they all actually are written in very similar fashion. So once you know one, it is really, really easy to pick up another one. Don't get overwhelmed by this. Just like with anything, there's a lot of tools for the job, but we'll come back to this so it all makes sense in the end. Just keep in mind that the syntaxes are very similar, so you'll be just fine. And I also want to let you know that probably the most popular, Jasmine used to be very popular, but it has now been overtaken by two things. One is Jest. As you can see, Jest is nice because it has everything in one place. You can just install this library and have all these little features that you need in a testing framework. Another popular one is Mocha combined with Chai and Sign-On. And this is, again, probably the most popular setup, but that's also because Jest is a lot newer. Most of these libraries follow the idea of behavioral-driven development, which is we describe what a function does and say what behavior we expect out of them. You remember the Chai assertion, right? If object has this properties, we expect it to have this property A. All right, does your head hurt yet? Luckily for us, if it wasn't for Create React App, we would have to npm install all of these again, set them up, and add them to our npm scripts to run all these tests and test coverages. But as you can see with Create React App, we have everything out of the box. Again, the best minds in the community are working on maintaining Create React App to always keep it up to date as all of these libraries update as well. Don't worry though, I'll show you in the upcoming videos how to actually set this up yourself as well. One other note. In our tests over here, Create React App uses Jest, and that's because Jest was created by Facebook. And if you remember, React was also developed by Facebook, which is kind of nice because they use it in their own production environment, and these tools are used together to work really, really nicely. And by the way, there's other testing libraries. We have Ava that does parallelism really, really well, which means it runs tests really, really fast. And then you have something like Tape that is really low-level, simple, light library. But as I said before, don't get overwhelmed. In short, if you get anything from this video, is that if you just want to get started and looking for a fast framework that can handle everything and has everything in one, well, just use Jest. If you want very flexible, extendable configuration where you can plug in some things, then use Mocha. Mocha is a little harder to set up because of all these things that we need to add on, but it's more flexible and, like I said, open to extensions. One last note. In our test, we're going to use two things that are sort of unique to React. One is something called snapshot testing that comes with Jest, which allows us to do some really cool things that I'm going to show you later on. And then another library called Enzyme, which was created by Airbnb and helps us write tests better for React components. Don't worry, I'm not just showing you these things because I think they're cool and trendy. These are implemented in most React projects that you'll encounter. And it's pretty much become the standard in the React ecosystem to use these libraries. So we're going to use them too. At the end of the day, though, we can agree on one thing. All these libraries have really cool logos. I'll see you in the next one. Bye-bye. Before we dive into coding, let's just talk about each one of the types carefully. Unit tests should cover all small, pure functions of an application. You may have heard me say that small, pure functions that take an input and return an output and that do one thing really, really well, one thing at a time, are the way to go. And it's the main principle in functional programming. Now, the awesome side effect of this is that it allows us to write unit tests really, really easily because our functions are so simple. Just give it an input and get an output and just test that. Based on an input, do you get this output? And this is one of the biggest benefits of functional programming versus object-oriented programming. But to recap, a pure function is a function that has no side effects, like affecting another part of a program and always returns something based on an input. It is deterministic, meaning that you can put in the same input a million times and you'll still get the same output a million times the exact same way, which, as you think about it, makes testing very easy. And by the way, React components are mostly pure functions those stateless components that don't have any life cycles or states, well, they get an input, which are props, and they return an output, which is a view. Those are really, really easy to test with something like unit tests. So unit tests are extremely useful. Like I said, these are the things that you'll see 90% of the time, and most of the time you're going to be writing unit tests. So we're going to do that too in this course. The one thing to keep in mind is that unit tests don't test the contract. And what do I mean by the contract? The contract is the connection between things. It could be a contract between a server and a database. It could be a contract between a function and another function. Maybe my sign-in function calls a load profile function. Unit tests would test the sign-in function and a load function, but not the contract between them, whether they integrate well together. The important takeaway is this. When it comes to unit tests, write code that is separated away nicely. Clean, functional components or functions, which make it easier to unit test because everything is small chunks. And this is going to lead to nice maintainable code in the long run. I'll see you in the next one. Bye-bye. Welcome back. Integration tests are all about cross-communication between different units of code. Comparing to unit tests, you'd probably use something like spies from a mocking library to ensure expected side effects instead of just asserting an output. Or you might use stubs to mock and modify parts of a process that are not inside of the specific test, such as mocking a database call. We can say, run in a test to a function that says get user to mock the database call and just fake it and return, let's say, a fake user just for the test. Also, as opposed to unit tests, a browser or a browser-like environment could help with the processes that are dependent on the window object. And this is especially true when we're working with React and rendering components. Now, integration tests is one of those things that has many different definitions and everybody has their own preference of what it means. Overall though, think of integration tests as connecting components to see how they work together. Instead of individual small units that unit tests test, well, you test the connection between them. The downside to them is that they are expensive, they're slower. There's more dev time involved in thinking them out and writing them compared to unit tests, which are much faster to run. And they also have a lot of moving parts. If you change something, well, your test will break and you'll have to change those tests that depend on that thing you changed. So integration tests can be what we call brittle, really, really fragile sometimes. And they are much, much harder to write. And unlike unit tests, you can write an infinite amount of integration tests. It's hard to say when you're done writing them or when you have this 100% completion because it's impossible to cover everything in every test case. And because they're also more expensive, as I just said, they're rare to see a company that has really good integration tests, unless they're a massive, massive company with a strong engineering team and a ton of money to spend on that engineering team. I recommend, though, to always start off with unit tests and then start incorporating integration tests as well. But they both work well together. Just pick your battles. I'll see you in the next one. Bye-bye. Let's talk about the final type of test, automation tests. Now, you may also hear the term end-to-end testing when it comes to automation tests. So keep that in mind. Automation tests, like I said before, are UI tests that are always running inside a browser or a browser-like environment because they need to simulate user behavior in these environments, such as clicking, typing, scrolling. And finally, they need to make sure that these scenarios actually work from the point of view of an end user. It's an important test, right? If your checkout process has a bug, the best way to probably test it is to actually go through that checkout flow and make sure that users can purchase whatever you're selling. Now, in an ideal world, we have automation tests everywhere. And if any of them fail, we know that our web app doesn't work. But it's important to remember that these tests are the hardest to set up. Imagine yourself creating an environment to run a test on different machines because users have different computers, different devices, different phones, different browser types, different versions. How can you really test for that? I mean, you can, but it's really, really hard. And this is why there's so many services that provide automation testing for you. Here's an example of a few of them. Yep, these are just a few of them, such as Nightwatch, WebDriver.io, Test Cafe, Nightmare, Cypress. The list really goes on. Automation testing is something you usually only find at bigger companies that have the budget to really spend money on this. Because there's so many edge cases and they're so expensive to implement that some developers go their whole career without ever writing an automation test. But I still want to cover it because it is an important topic. Here's a quick lowdown though. If you just want to get started and not worry about cross-browser and have all the tools in one, probably Test Cafe is your best choice. Or if you want the one that has the best documentation online, well, WebDriver.io is really great. And if you want really simple ways to automate user actions or do something cool like web scraping, well, Nightmare.js is pretty good. Now, the important thing with automation testing is that, like the other name suggests, end-to-end testing, you want to test the entire process of your UI. And you might be thinking, why do we get the machine to do it? Why can't we just hire people to test for us and do automation testing? And that happens. Many companies, instead of writing these scripts, simply hire people to do automation testing. And at some companies, you have people like testers that do this for you and make sure that the app works as intended. And there's pros and cons to both of these, and that's something that it will really depend on your company and your work environment. The main thing I want to suggest, though, is that we want to create two different testing processes. One for running unit tests and integration tests, and a completely separate one to run these UI tests, these automation tests. That's because UI tests take a longer time, especially if we worry about different browsers and different devices, and they also cost a lot more money to run them repeatedly. So you'd want to run unit tests and integration tests often, probably in your terminal as you're saving your changes to your code in your local environment, and maybe run UI tests once a day or a couple of times per week, or maybe just before you merge into the master branch, before you release it to production. For now, though, that's it for automation testing. I'll see you in the next one. Bye-bye. Andre, more slides. Can we just get to coding? And I know what you're thinking. I know the easiest thing to do is for me to just go to my Sublime Text and start coding so you can follow along. But I really want this course to build the foundation, because I can do all the coding in the world, but if you have these fundamentals and we talk about them first, and as you code along with me or you do the exercises, you truly understand them from the basics, then you're going to retain a lot more information. So bear with me. This is going to help you develop into a better developer. This is the last slide before we get into some coding. I just want to show you one last part, and that is our unified picture of testing now that we've talked about everything. We're going to be writing tests for our RoboFriends app, and if you remember, we have our main file, app.js. And the way we're going to write tests for it and other subcomponents, and maybe even reducers and other parts of the Redux environment, well, we're simply going to do the .test.js, which with our create React app setup is going to say that, this is a test file. Let me run it through Jest. Keep in mind that tests are meant for development. You're never going to ship your test libraries or your test code into production. Most of the time, you're saving these libraries with the flag -- save dev and npm because they're only used for development. In development, as you're writing your tests, as you're writing your code, you have something like Jest running in the background that has the scaffolding, the assertion library, the test runner, the spies, mocks, and stubs that we need to read the tests, run the tests, see which tests pass or fail, and also output a code coverage so that we can work on our project, and when it's ready, it passes all the tests, it has all the nice tests that we need, we can then send it to production without all this stuff that production doesn't need. And remember that we're running these tests. We can run them in the DOM, we can run them in a headless browser, or we can just run them in a JS DOM, which we are going to do. We're going to use JS DOM because it's the fastest and the simplest to run our tests. All right, time to get to coding. It's going to be a lot of fun. I'll see you in the next video. Bye-bye. Now, I know that Create React App already comes with Jest and other testing tools pre-installed, but I think it's important for us to understand how it works so that we can also build something like Create React App ourselves. So I'm going to start from scratch and set up a few testing examples for you. Now, Jest here has great documentation. Once again, with any library, you go through their guide and they provide a lot of info. So let's get started by installing Jest. Or first of all, let's create a project folder. I'm going to create a project folder called test, and we'll just go into that folder and run our usual npm init-y to create an npm package. And we also want to create a script.js file. And let's open that up in our favorite text editor. Looking nice and pretty. Perfect. Now let's look at package.json. And obviously the first step we want to do is run npm install Jest. And actually, let me cancel this. Remember that Jest is for development purposes. We don't really need it as a dependency for our app. So usually when you install Jest, you want to do npm install -- save dev. Oops. Let's try that again. Jest. And remember that with the newer version of npm, when you do npm install Jest, it assumes the -- save as a dev or as a dependency. So that's why I didn't do the -- save here. Now, while this is loading, let's go into our scripts and change this to the test command. And all we need to do here is run Jest once it's installed. Not sure what happened here. It looks like a bit of an error. Let's just close this out and run it again. Now, while that's loading, let's go into our scripts file and think about what exercise we might want to incorporate. And I think having us incorporate a simple Google search functionality might be a fun little exercise. So let's do that. It looks like everything was added, so let's just hit clear, make this a little bit smaller. And again, if we go to package.json, we see that it's part of the dev dependencies. Not the dependencies, but dev, because we did the -- or -- save dev. In the script.js file, let's say that we're Google and we have a variable. This is going to be a simplified version of their search algorithm, but the principles are going to be the same. So let's say that the Google database has an array of all the websites that they've indexed. Let's say the first one is cats.com. Obviously, it's the internet after all. We also have souprecipes.com. Everybody loves soup. We have flowers.com. And let's just add one more. We'll say that we also have animals.com. Pretty basic websites. And these are all the websites that Google can search for you. Obviously, in real life, this list might be a little bit bigger. All right, so there is our Google database. And you know what? While we're at it, let's just add a few more. catpictures.com. And maybe my favorite cats.com. All right, and I've added these last two because maybe if somebody searches for cats in the Google Chrome browser, well, we might want to show them these three links. Again, let's create a function, and this will just be the Google search function. And this function will take the search input that the user provides, so whatever they're searching for. And from there, it does a few things. First, we want to say, it's going to be a very simple algorithm. Obviously, this is way more complicated on Google, but the idea is we search something, and if there's some sort of a match, we want to return it. Let's just say that the Google database is going to get filtered. And using the filter function, we'll say that each item in the database is a website that is going to get filtered. And all we need to do is return the website that includes. So this is, let's say, cats.com. If it includes whatever the search input was. Like I said, very, very nice and basic Google search algorithm. And we also want to return these matches to the user because, well, that's what Google does. But let's say that we want to make sure, because hypothetically this database can get really, really big, we want to only return the top 3 results. So we can just say, let me make sure I spell that right first. We want to say if this dot length is greater than 3. If we have more than 3 matches, then we'll just say matches dot slice and just return the first 3 results. Otherwise, just return the regular matches. Let's make this smaller so we can see. All right, let's test this out and see if it actually works. I'm going to run the Google search function. And let's say that the search input that I'm going to put in will be soup. And let's just console.log this to make sure that whatever the output is, well, we log it into our terminal. Let me save. And again, with node, we can just run this node script.js. All right, look at that. I have soup recipes. If this changes to cats, I get cats.com and myfavoritecats.com, but not catpictures.com because it doesn't match cats. If we add another website here, let's call it myfavoritecats2, and I only search for cat. Oh, and make sure I add a comma. Always forget the comma. Let me clear this and try that again. All right, I only get 1, 2, and 3 results because we're doing this little slice. We're only returning the top 3 results. Awesome. We've just implemented Google on a simpler scale, but Mind you, this is pretty much how Google works. All right, so that was fun, but how can we test this? Let's say we were at Google and we want to make sure that this Google search function works properly because it's an important function for our app. Since we have Jest installed, let's run npm test and see what happens. npm test. It just says no tests found because we haven't written any tests. But you can see over here that Jest automatically looks for anything that has either a folder that has the underscore tests and anything inside of it, or it's going to look at any file that has the spec or the test.js syntax. By that logic, I can just create a new file, script.test.js, or I can put spec in here, which is also common, and I hit enter. And if I run this again, I get a fail. It says your test suite must contain at least one test. All right, let's clear this. So how can we write a test for our Google search? And we'll get to that in the next video, but just to make sure that our test passes, I'll just show you one quick way that we can write unit tests in Jest. And that is, we have now an it function. And the first parameter of the it function, and again, this comes with Jest, but if you download other testing libraries, pretty much all of them have this function as well. Like I said, all these libraries have a very similar syntax. So if you know one, you can transition into the other quite easily with a few minor changes. So the first parameter in here is some sort of a string that will appear here. So let's just say this is a test. And then the second parameter is a function, which is the test that needs to run. In our case, we don't really have anything, but let's save this and run npm test. Whoa, look at that. We have our very first test. That was pretty easy, right? All we did was npm install Jest, and we already have this new it function, and we can run tests. And we see that this is a test passed in 1 millisecond. That's a pretty fast test. Everything is green and nice. Kind of feels good. Gives you a nice boost of dopamine. All right. In the next video, we're actually going to start writing some tests for our Google search. I'll see you in the next one. Bye-bye. Welcome back. Let's start to actually write a test for the Google search function. The first thing we want to do is obviously have access to this Google search function, but in our test file. And that's simple. This is simply just JavaScript. We can just export this function and import it in here. Now, because this is Node, and we're not running in the browser or using Babel or Webpack, we don't have the import and export statements yet. Node is working on that, but for now, they're still using CommonJS, which, as you might know, has this syntax, module.exports equals, and we'll just do the Google search. We're going to export this, and then finally, we can import this at the very top of this test by saying const Google search equals require from the script file. Let's save that. And just to test it, let's just console.log this and do Google search. Save, run npm test. All right, so we have our console log of Google search. That's on script.js. But also in the test, we see that we're logging out function Google search, which is great. I'm going to comment this out for now because we know it's working. We don't want a console log. But you might have also noticed that it's kind of annoying running npm test over and over and over. And luckily for us, with Jest, we can do a nice, easy command. -- watch, and then we give it what to watch for. In our case, all JavaScript files. So anytime we make changes to any JavaScript files, Jest is going to watch out for those and have the test running constantly. Let's see what I mean. I'm going to save this and run npm test. And if you're wondering why I can run npm test and not npm run test, that's just the default of npm. If you do npm start or npm test, you can run those two commands without the run word. But if you do anything that you created yourself, like npm bake a cake, you have to do npm run bake a cake. All right, so now it's running. If I change anything in here to, let's just have save it, you see that it's now changing. If I change this, it's constantly updating with the new test. But nothing is happening in here yet. So let's write an actual test that we can use. So now that we have the Google search function, we want to test it. We want to say Google search, give it some sort of a dummy input. Let's say test, and somehow say whatever this returns should match whatever. And remember, that's an assertion library. We want to make an assertion. And you may notice one issue here. What about the database? Well, we'll have to export this database as well, right? And we totally can. We could do Google database and add it to the module exports. But is that realistic? You see, in real life, you're not going to just export the database and import it into a test and have the test actually go through the database. That's really expensive, really slow, and a huge headache. Ideally, you want to mock it. You want to pretend that we have a database in here so that it makes tests run faster. Let me show you how we can do that. We can just say db mock, a database mock, and this mock will have some dummy database, which isn't actually our real database, just something that we can test on. So let's say this one has dog.com, it has cheesepuff.com, it has, let's say, disney.com, and it has dogpictures.com. So completely different from our real database. All right, so we have this now, but the problem is, well, Google search up until this point was using the Google database. And if we run this function in script.test.js, well, we don't have access to that database. We'd have to manually change the function and make sure that it filters through the db mock. And a good way of solving this issue, and the way you want to write your functions, is, again, you want them to be pure, and you also want to add things to them like a database through something called dependency injection. That is, in order for us to make this reusable and use it in other parts of our code base, have the database injected into Google search so that anybody using it can, like I am in the test, can inject this db mock instead of the real database. And that's really easy to do. All we need to do is pass it a parameter of, let's say, db, and I'm going to change this into db. And now this Google search is more extensible. We can add whatever database we want to filter now. All we need to do is, when we call the function, is to add a second parameter of Google database. If we comment that out and go back to our test file, we can enter the db mock database. Let's save now and see what happens. All right, test is passing, but we're not really testing anything right now. We're just returning things and running this function, but that's not where we want to test. It's not very meaningful that we run this function. We want to assert that this does what we expect it to do. And again, just like we had the it keyword, just gives us a nice little function for us to use. If you go to using matchers, we see that in their documentation, they have the expect and to be. And they have a few other things that you can use: to be undefined, to be defined, to be falsy, truthy, and they have a ton. For now, let's comment this out and say that we expect hello to be hello. Hello to equal hello. All right, let's save that. All right, everything is passing. But if I change this to no and save, I get a failed test. It says it expected the no value but received hello. And it's got pretty nice output. It shows you which line failed and what the test failed at. Using that logic, let's change now the Google search to have expect. And you know what? Let's keep this test because I like this test. We'll do hello at hello and call this it is a silly test. And create another test. Again, we can just have as many as we want. And this one will say it is searching Google. And in here, we'll have the function. Let's add a space here because that looks nicer. And we'll say that we expect Google search, and we can just copy this. We expect Google search, and we're running that function with test db mock. And here we can use, instead of to be, we can also do to equal. And within the to equal, now let me just create a new line just so you can see it. It's going to say we expect it to equal an empty array because there's no test here. Let's save. Oh, and I forgot a little bracket here. We want the expect to have the result of this. So we need an extra bracket over here. So make sure you get that right. Let's save. Oh, and we don't need that now. Perfect. Again, maybe not having it on two lines is better so we can see. So we have the expect function that runs this, and to equal to test that this equals the empty array. We can now add another line, and let's say that now we want to expect Google to test dog. And if dog exists, we want it to include these two websites. So we can add dog.com to this array, and also dogpictures.com to this array. And let's save. All right, this is running and passing. We still have two tests because, well, there's only two of them. But if I change this to, let's say, just DG, I'll get an error because we got something different than what we expected. We expected a different array. There you go. We have our very first test. I'll see you in the next video. Bye-bye. Welcome back. Let's finish up testing our Google search functionality. Because with tests, the more you have, the better it is. In most cases anyway. Because these are never going to go into production, it's just for development purposes, it never hurts to have a lot of tests that cover a lot of scenarios, because that way we just cover our bases even more. And don't worry too much about repeating yourself, or the do not repeat yourself rule in programming when it comes to tests. It's okay to repeat yourself every once in a while, especially if it makes the tests really readable for other people reading your code. Once again, these are never going into production, so it's always better to have more tests than less tests. So let's test a few more cases with our Google search function. Let's say that we also want it to work with undefined and null input. And that we want to make sure that this function is going to work. And let me just copy this expect assertion. And within here in the Google search, I'm just going to say undefined. And we want that to equal an empty array. If we somehow get a weird entry on an undefined input from the user, we still want to return an empty array because maybe on the front end, we're still displaying an empty list. Let's save. And that passes. We now have 3 tests. And let's also test for the null case. Again, we'll copy this. And we'll test for null as well. All right, our tests are passing. Perfect. And you can see how nicely outlined they are in Jest for us. Finally, we also want to check, if we look at our script, that we return no more than 3 matches. That's an important feature of our app. Once again, let's say it does not return more than 3 matches. And let me make more space for this so we can see. And once again, you can see a lot of repeating here, but it's good. We're writing tests. Let's say that, again, I'm just going to copy this because I am lazy to type. And we'll say that we want when we search .com, which all of these have, we want this to equal an array with 3 items. How can we do that? Again, this is just simple JavaScript. We can just do a dot length in the expect bracket, which will return, hopefully, 3, even though we're doing .com and has 4 items. Because of our function, it should return the length of 3. So let's test that. Look at that. Our test pass. And another advice here. Just because your test passes doesn't mean it's always correct. It's always good to start off by making your tests fail and then trying to make them work. Let's just make it fail by adding 4 in here and hit save. And all right, we see that we expected a value to equal 4, but we received 3. That's good. If we change that to 3, everything is good, and you can play around with the inputs a little bit more. I think you're starting to get this, right? It's not that bad. It doesn't look that intimidating. And yeah, when you look at other people's tests, there might be a few more methods that they add other than to be and to equal, but the basic principle is the same. We just have a function that we run tests in. That's it. One final thing. We can group all of these because, remember, with our apps, things can get bigger and bigger and bigger. We can group tests that are similar, especially in this case, the ones that are doing Google search, with another function called the describe. And describe will say, describes the Google search. And this is the exact same way that the if block was described. The first parameter is a string that will be displayed on the test, and then the second one is a function. And we can enter all of these tests inside of this block. So now, if I save this, I see that the tests are grouped together. And I know that all these tests that we're running are under the Google search function. So that when we have hundreds of tests, we can see which ones are failing and where we want to target to fix our tests. All right, more exciting things in the next video. I'll see you in that one. Bye-bye. Welcome back. We got our tests to work, and Google search right now is working pretty nicely. I'm pretty happy with it, and I think we can move on. Let's create another script and have perhaps a more realistic or a harder function than this to test. So I'm going to just add a new file and call it script2.js. And we definitely want to write some tests for it, but for now, let's just write our function and what it's going to do. Now, one of the harder tests to write, and something that you might be thinking of, is asynchronous tests. I mean, right now, you can see that with Google search, we can copy this with pretty much any function. And you might see why pure functions are so good to test. I mean, you're just testing function. You're just adding some random inputs and making sure that the outputs are what they're expected. Very nice and simple. And they're all just synchronous, nice tests. But in real life, we most likely have fetch calls or API calls that are asynchronous. How do we test for those? Well, in this video, let's tackle that. For this exercise, I'm going to use an API that I really like called Swappy. And yep, that stands for the Star Wars API. It's free and it's awesome. I recommend it in the other course as well. So some people might be familiar with it. But yeah, it's great. You can see here that you can request planets, you can request people, you can request starships, all from Star Wars. Yeah, pretty awesome. Using the Star Wars API, you can see that this is the endpoint that we can hit to get the JSON response. Let's create a nice little function for us to use that we can test. Now, fetch in Node won't work because if you remember, fetch is something that's implemented by the browser. And it's on the window object. But in Node, there's no such thing as a window object. So there's no window.fetch. For that, we need to install something called Node Fetch. And there's a few other libraries that you can use, so you can do fetch calls from Node. But let's just stick with this one for now. This way, we can now have fetch in Node. And again, we import it with the common JS way because imports and exports are not available yet in Node. And then just import Node Fetch. All right, and in here, let's do a const get people from Star Wars. And let's say this is going to receive the fetch. Remember, we're doing a bit of dependency injection here so that we can test and we can keep this nice and easy to test as possible. In here, we can say that we're going to return fetch. And I know this is a little bit redundant because we could just not have an input and have fetch, but it shows, I think, dependency injection really well. And this isn't something that you necessarily always need to do. But for this purposes, I think it's a good way for you to get familiar with dependency injection. In here, we're going to have the Star Wars API. Let's go back to what they had. And let's copy this and say that we want to request the people API. And if you remember, we always need to do our classic .then response and then run the JSON method on the response. And then finally, we have our data, which will be the people that it returns. So let's say in here, we're just going to return an object that has a count, because if we go to people over here, because we want to get all the characters, we get a count variable of all the characters in the API. So let's do that. We'll say count. And actually, this should be data.count. And then we'll do results that will just have the data dot results, which will have all the people in an array and each person in an object. All right, let's save that, and I want to make sure this works, so we'll just do console.log, get people, and pass in the fetch function to it. I'm going to save, and let's just run node. Let me clear this for now. And actually, just because this is asynchronous, a nicer way of doing this is just in here, console logging the data. Let's save and run npm script2.js. And we have to wait a bit, but you see over here that, all right, we got all the characters with count to 87, and we got Luke Skywalker. What else? We got C3PO, R2D2, all the main cats. Awesome. This is working. And you know what? While we're at it, just for fun, since this is using a promise, let's also add the async await version of the code. And let's just remove the call and just say that get people is going to use the async await. So that means in front of the function, we're going to do async. And now we can use the await keyword. So we can just say const get request equals await the fetch call. And now we can say that the const data again equals await the get request .json, and now we can remove the .then and keep everything the way we had it. Let me add the semicolons, and let's just make this smaller so you can see better. And we can move this on this line. You can decide for yourself what looks cleaner. But let's test out this as well to make sure that it works. So get people, and we'll add fetch. Going to save and run npm. Oops, not there. Run it here. npm run, nope, node script2.js. We'll wait a bit, and there you go. Everything is working. I don't know why I decided to show that in the test video, but I'm sure somebody out there is going to find this useful to compare promises and async. A little bit of a tangent, but let's get back on track here. Let's actually start writing tests for our async code. Again, the first thing we're going to do, and I'm going to remove the get people and console log from here. Let's save. And I'm going to create a new file, call it script2.test.js. And within here, we want to do a few things. First, we want to use the fetch function. So we need the require node fetch. Again, because we have used dependency injection, and we need the parameter fetch for the get people. And then we also need the function from the Swappy API that returns the get people. For now, let's just say require script2.js. Oh, we don't need the JS. But remember, because this isn't a node package, we need to actually give it the path. All right, so let's export the function. Let's just export both of these for now. We'll say module.exports. And we export them in an object. We'll say get people. And instead of doing get people again, shorthand with ES6 is to just do get people and get people promise, which is the same thing as get people semicolon get people. Property and value, property and value. All right. So now within here, we'll have access to our functions, both of them. Let's take a break, and in the next video, we're going to finish up this test. I'll see you in that one. Bye-bye. Welcome back. Let's start writing some tests that are for asynchronous code. If we go back to our script2.test.js, we can start off our first test by saying it calls Swappy, Star Wars API, to get people. And again, same syntax as we've seen before. In our first test, what can we do? Well, we can say Swappy dot get people. We'll give it the fetch API or the fetch function, and then do dot then. And like I said, you could pass down URLs here, and we could do something called mocking, which we'll talk about later. For now, we're just sticking with this method. But let's see what we can test. We have the API that we're calling. Again, it's going to return us a ton of data. So again, we do the dot then, just simple JavaScript. And this dot then is going to return us some data. Remember, it's going to return our data, or it's going to return our count and results. So in here, inside of the dot then block, we can do our assertions. Expect data.count to equal 87. Because remember, if we go back to the website, the count is 87. So hopefully data.count matches 87. Let's see if that's the case. I'm going to save and go back to running our test. Let me clear this and run npm test. And we'll need to press A to run all tests. All right, so that worked. That wasn't too hard. We didn't do anything too crazy. What if we add another test? I'm going to add another test here, and it's going to say calls Swappy to get people with a promise. Now, this time around, we'll use get people promise. Let's save. All right. Is that actually working? It looks to be working. I mean, we get the tests, 6 of them that have passed. But remember what I said. We always want to make sure that we fail our tests and check that the tests actually are checking what we want to check. One tool that we can use with Jest is something called expect.assertions. And assertions are, remember, assertion library, are these things. These are assertions. So using the expect.assertions, we can say within this if block, we expect 1 assertion. If we had 2, then we should say we expect 2. And this is a good way to test that these things are actually running, especially with asynchronous code. Let me do 1 here. I'm going to save. Whoa, what just happened? Our expect.assertions 1 failed. There were 0 assertion calls. So something's happening here where this test is passing, but this is never being called. And this is a little gotcha with asynchronous tests. You see, when this happens during tests, it's really hard to debug because it's easy to not check that they work properly. The problem is that the tests are actually completing as soon as the get people gets called. And remember, a promise returns a pending state. So this is going to get returned before we actually receive the data. How do we get around this? How can we tell the test, hey, don't just pass this test because nothing happened and we just returned a promise with a pending state. Wait until this is actually done and then keep going. There's a few ways to do this. The first way to do it is to use a single argument called done. So instead of having an empty parameter here for the function, we can have done that gets automatically passed to a test. And this says, hey, just wait until the done callback is called before you actually say this test is finished. And you usually put it right after the expect call. So let's say this is now done. So let me save that. All right, it passed. Now we're saying, hey, don't pass this test until this is done. Just to test, if I change this to 0, this is failing because we have one assertion call. Awesome. Now, this is one way of doing it. And the neat thing with this is that if for some reason if this fetch call fails, let's say that in the script2.js, this is actually an incorrect URL parameter that we're sending. Maybe we misspelled people. If I save this, you see that I get an error, calls SOPy to get people, and I get an error here, so that the test waits until I'm actually done. Very nice. Now let's fix this, bring this back to 1, and talk about the other way that you can do this. And this is really easy. If your code uses promises like we have, there's a simpler way that's probably less confusing for most people to handle asynchronous tests. And this is another thing that I really like about Jest. We can simply, instead of doing this, just return the promise. And Jest is smart enough to say, oh, because we're returning this, I'm going to wait until this promise returns. And if the promise is rejected, the test will automatically fail, which is very nice. Again, let's save this. Everything's passing. If I misspell the API URL again, you see that the test automatically gets failed. Now, this is a little tricky. You have to always make sure that you return the promise. If you omit this return statement, as we saw, your test will complete before the promise actually gets resolved or rejected. So here's a tip. When running asynchronous tests, always do this. Always do the expect assertions. Always test out that your assertions are being tested. So let's finish this off. Let's add a few more lines. We'll say that in here, we're going to add 2 assertions. And again, we want to return here. And we'll add another assertion that says that we expect data dot results to have a length and what can we use here? We want to check maybe that the results, we get at least 5 people, or that the length is greater than, let's say, 5. Luckily for us, there's a Jest cheat sheet. And this Jest cheat sheet, well, try to say that fast 5 times. That's pretty hard. Actually has all these things that you can use for the tests right in here. Super, super useful. These are pretty much all you need to write the perfect tests. And we see here that we have the to be greater than method. So let's use that. I'm going to say to be greater than. And again, this is why I love Jest and most assertion libraries, they just make everything read nicely in English, so you understand exactly what's going on. So I'm going to say to be greater than 5. Let's save. All right, we get a few errors, so let's fix this test. 2 assertions to be called, but we only got 1. Why is that? And I get an error, length of undefined. And let's log out data to see what we're getting here. So let's do console.log data.results. And I'm getting undefined. So it looks like over here, oh, there you go. I've noticed my error. I misspelled results here. You're probably laughing at me right now, but this happens a lot more than you think. All right. So let's see that. All right, that's good. We're getting some response. Let's remove the console log. Hit save. And again, this is another good reason to write tests, right? Because I wouldn't have caught that mistake until I've actually run the app. So I see here that I just have a simple type error to be greater than, again, terrible at English. This is THAN. All right, everything is passing. And what you just witnessed is how tests usually work. They're constantly breaking, and you try to get to this green state. And when you get to this green state, it's like, hallelujah, this is so nice. It feels so good to have everything green. And things are working. Awesome. All right, I think that's good for now. In the next video, I want to talk to you a little bit about mocking. I'll see you in that one. Bye-bye. Welcome back. Now, one thing you may have noticed, if you're really paying attention, is that these tests are fine for now because the Swappy API is fairly fast and we're getting the data back fairly soon. But imagine if we had many of these tests. Imagine if we had APIs that return lots of data that takes a long time to actually get to. You can imagine this growing bigger and bigger until it takes forever for our test to run. I mean, it only took 2.557 seconds, but with more and more tests, with more and more asynchronous tests that we wait to actually get a data response, it's going to take longer and longer. And if we're developers and working and saving our work constantly, if we have to wait a couple of minutes for our tests every time, that's really going to slow us down. How can we improve this so that we're not always doing this fetch call? Well, we can use something called mocks. With a mock, we can fake a function and just pretend to have it running. So that we can use this mock to let us spy on the behavior of a function that is called indirectly by some other code, rather than just testing the output and waiting for the asynchronous code to complete. And you can create mocks in Jest really, really easily. So let's do that. Let's create a mock here to speed up our asynchronous tests. The first thing we're going to do, let's create more space here. I'm going to, again, create a new test. We'll just call this get people returns count and results. And in here, we'll do the same thing. Second parameter is a function. Now, we're going to create something interesting. We're going to mock this fetch because, first of all, Node Fetch is a third-party library, and if we've really tested out the library code and we checked the GitHub repo and they have tests, we don't need to test that it works. We can assume that the fetch function works as intended. So let's just do a mock fetch and mock fetch, and this is going to be a variable. So let's just say const. We can mock the fetch, and the way we can do that in Jest, again, if you remember, this is something that comes with Jest, mock, spies, and stubs. Otherwise, if you're using something like Mocha, you'd use sign-on. But with Jest, we can just do Jest dot fn for function. And we can do something called, again, this is all in their documentation. We can do something called mock return value. And we can just return something as if this fetch function was called. So what does a fetch function usually return? Well, we know that it returns a promise. And let's just for now say that it's always going to resolve. So that is a resolved promise. And inside of this resolve, let me make this on a new line just so we can see it better. That's better. In here, man, let's make this a little bit smaller. We want to resolve to an object that is JSON. Because if you remember, we always have to do the .then response.json. So we can just mock this whole thing out. We can say that JSON, so the object that we return, is going to be a promise. So we're going to resolve a promise with the JSON method. And this method, again, is a promise. So again, promise.resolve. And this promise, again, with this part, we're doing this, the .json. And then we get the data. So we can say that within the resolve, we'll have count equals 87. And the results will be, let's just create an array that says 0, 1, 2, 3, 4, 5. Let's save this and get a bit of a syntax error. Let's fix that. We have an unexpected token, and I forgot a comma over here. Classic commas, they always get me. All right, so now we just mocked the fetch call. Instead of calling this get people promise and wait for the data and get the data.count, data.results, we're actually just doing that automatically, assuming that the API works. So we can just test our other parts of the function. Again, because this is still asynchronous, we're returning a promise, remember. We'll want to do a return swappy.get people. Now let's do get people promise. And in here, we can, instead of the fetch, do the mock fetch. We're mocking the function that is fetch. And this is how, when we test, we can use dependency injection to make sure that we're testing different functionality. And you might remember this from integration tests, but without actually using up all these resources. We're trying to be as smart as possible. Now we can have the .then, and we're going to receive the data, just like we did up above over here. Now within here, let's do a few tests. We want to expect the mock fetch. That's right. Because we use jest.fn, we now have an ability to listen in, because in jest, this is also a spy. We can spy on this and see what this function did inside of this function. So what did mock fetch do inside of get people promise? I can say expect mock fetch dot mock. Again, this is in the jest documentation, to have a calls. So how many times has this been called? I'm going to say length. So the number of times it's been called to be 1. Let's save. And this is passing. But remember, with asynchronous tests, we want to always do the expect dot assertions to make sure that they're being called. So in this case, we only have 1. Everything works. If I change this to 0, that fails because we actually did call the mock fetch. This function called the mock fetch once. Very cool. What else can we do? Well, another thing we can do, now let me just copy this. We can expect mock fetch, have another method called to be called with. And we can test to see what this was called with. In our case, it should be called with this URL. So again, let's put it in here. Let's test this out. I'm going to save. Oh, and I actually did make a mistake. We want to do expect, again, the mock fetch to have been called with the URL. Let's save. Oh, and remove the bracket. All right, it's actually passing, but remember our assertions is now expecting two things. So I'm going to save. Do you see how it took a little bit more time this time? Again, because we're repeatedly calling this API, it's taking a little bit more time, this time 3.981 seconds. But with the mock, because we're doing promise.resolve right away, it's a lot faster. And that's passing. If for some reason I change this to and we expect it to call planets instead, we see that it fails because we expect the get people to actually get the people, not the planets. Very cool. All right, let's do a few more. Well, let's just add, again, copy and pasting in testing is not bad. Let's just copy and paste this and expect that things work the exact same as they did in the above with the regular fetch, but this time with our mock. So we can save, go back, and I have a test failing because now our assertion number is 4. Woohoo! Everything is passing. And if I change this count to 89, and I change this to 89, but let's say to be greater than 10, it should fail because our results only have 6 items. There you go. But if I change this to greater than 5, our tests are passing. Very, very cool. And there you have it. Other than learning a few methods, such as to be greater than or to equal, which you can always check in the documentation when you write a test, everything is pretty simple, right? Once you get the hang of it. We have synchronous tests that are very, very easy, and we just have an expect assertion. And then we have asynchronous tests that we just have to remember to return and make sure that we have access to the promise, whatever it returns. And then we can also, to avoid long-running asynchronous code, such as API calls or maybe even a database call, to mock. And mock functions, also known as spies in Jest, because they let you spy on the behavior of the function, is called by our test, and it's going to spy on what is happening. And you saw that getPeoplePromise actually runs this mock fetch that we created. And all you need is this syntax. And here we just added extra things because we wanted a certain behavior. But even just doing this, we could have seen that mock fetch would have been called with this URL. Jest is an awesome, awesome tool. If you work with other libraries, you'll see a lot of the similarities. Like I said, mocks, stubs, and spies can also be seen in sign-on, especially if you work with Mocha. But overall, the principles are the same. And you can see that tests can be fun because we're just testing logic. And nothing feels better than getting all these green passes. All right, that's it for now. I think it's time for us to get into some React testing and testing our RoboFriends app. I'll see you in the next one. Bye-bye. Welcome back. We've learned a little bit about testing, but how about testing our React component or our React app, our RoboFriends app? If we take a look at our folder over here, I have the RoboFriends PWA because it's now a progressive web app. And based on what we've learned, we might go to the Actions folder, Constants folder, maybe the Reducers file, not folder, I guess. And because these are just simple functions, we might know how to test them. But the one thing we haven't really discussed is how do we test these functions that are React components? I mean, how do we actually do that? And there are ways that we can figure out to test this with the methods that we've learned so far. But there's a great library that simplifies things for us, and that is Enzyme. And this is a library by Airbnb that is pretty standard in the React community. If you want to test your components, then you're most likely going to use Enzyme. And Enzyme is, again, a tool that allows us to say, hey, in our tests, just render this car component, and Enzyme is going to give us a ton of methods for us to test, hey, did the div get rendered? Did the image get rendered? Did the name and email get rendered? So in this video, let's install Enzyme and have a look at what it offers us. Now, they have great documentation here, and you can see that based on our React version, they have different things that we need to install. And since we're using React that is higher than 16, if we take a look at package.json, we see that we're using React 16.2. You might be using a higher version of React, but most likely you're going to be using a version that is higher than this. In that case, they give us pretty good information of what to do and what we need to install. So we need to install the Enzyme library, as well as this Enzyme adapter React 16. So just a special adapter that we need for this newer version of React. I'm just going to go ahead and copy this. And you see that we're doing -- save dev because it's a dev dependency. All right, we have Enzyme installed with the Enzyme adapter. Now, if you go through their documentation, we need to do a quick setup for us to be able to actually use Enzyme. And again, this is because we're using a newer version of React. And I want you to keep in mind that this isn't actually difficult when you see me have these special cases of libraries and we need to do some sort of a setup. Most of the time, all these libraries have documentation for you to get started. I mean, their goal is for people to use them as much as possible, so they're going to make it easy for you to understand and set up. With Enzyme, what we need to do is create something called a setup tests.js to set this up. So in our source folder, we can just say new file. We'll call it setup tests.js. And within here, we're going to import something called configure from Enzyme. And again, all of this can be found in their documentation, so don't get intimidated by this. I had no idea how to do this until I actually read their documentation. Just on their introduction page, it'll show you how to do this. And then finally, we also want to import something called an adapter. And if I can spell, that's how you spell adapter, from the Enzyme adapter React 16 library that we also installed. And then finally, we just need one single line here, and that is to say configure the adapter to have a new adapter. If you really want to know what this does, you can go through their code on GitHub, but just by looking at the name, we say that it's just configuring our tests. All right, so that's set up. What can we do? How can we actually test our components now with Enzyme? Well, Enzyme gives us mainly just three things that we can use. Let me show you what they are. One is something called shallow, the other one, something called mount, and then the third, a render. And these are functions that we can use from the Enzyme library that we just used. And from these three, we're able to do something really, really interesting with our components. You see, in an ideal world, to do a test, we can render this whole thing and make sure that it returns what we expected. Like I said before, to make sure that we're returning a div, perhaps with these types of class names, that we're also returning another div inside of it with name and email. So just like a DOM, we need to figure out if it renders exactly what it needs. And just by looking at the names, it looks like Enzyme provides for us a way to render, mount, and shallow this component. So what do these all mean? And I'm going to give you a heads up. Most likely, 90% of the time, you want to use shallow. And shallow is what we're going to be using in this course. There are some cases that you might want to use mount and render, but just keep in mind that with Enzyme, we're pretty much just using this, which makes it very, very nice and simple. The very first thing, the one that we're using most, what does shallow do? Well, first off, let's create a test file here because, well, we're not going to import Enzyme in our actual component. So within the components file, I'm just going to say new file, card.test.js. And now let's import Enzyme here, as well as importing our actual component. So again, we're going to import card from the card.js file. And now, let's just for fun, see what happens if I do shallow card or the card component. And let's just console log this. Now, how do we actually run this test? Well, if we go to our package.json, we haven't installed Jest. But remember, because we're using create React app, this comes built in the React scripts. It has all this stuff set up for us. So we can simply run npm test. And we get a bit of an error here. We say that React is not defined. That's because, remember, we're using JSX here. So we need a way to read JSX. And if you remember, with any component, we always import React from the React package. All right, and it says that our test suite must contain at least one test because we're not really testing anything. But at the bottom here, we see that we have a shallow wrapper of length 1. So what does shallow do? Simply by running this syntax, we're saying, hey, shallow render this card component. And shallow rendering is useful because it just renders the card component. If the card component, for some reason, let's say had another component inside of it, that is the hello component, well, it's not going to render that as well. It's just going to shallowly render just this component. And it's useful because it constrains yourself to testing one component at a time, one unit, as you might remember. A unit test is something that just tests one unit at a time, one small piece at a time. And this ensures that your tests aren't indirectly asserting on a behavior of a child component like the hello component. So that's why I'm a big fan of the shallow rendering in Enzyme. Ideally, you just want to test one thing at a time without affecting all the child components. And this keeps your tests nice and clean. Now, the cool thing with shallow is that we get a ton of methods that we can now use on this card component. For example, now, because we've rendered this, we can use our good old friend expect to say, expect the shallow rendered card component, and then we can say to equal 1, and we'll just give it a length property here. And again, we want to wrap this in our it block, expect to render card component. And now we can just put this inside. Let's save. And there you go. We have one test passing. And this shows that, all right, the card component, when we render it, it's going to actually render something to equal 1. I mean, it's a silly test, but that's nice. We were able to just render nice and simple card component. Let me remove the hello from here. Now, what about these other two? These other two things, we're not going to go into too much because they have their specific use cases. Like I said, most of the time you want to use shallow and keep your tests nice and simple and contained. But mount does what's called a full DOM rendering. It's ideal for use cases where